welcome to, because Chris reminded me this morning, meeting number 13. And I told Chris recently that this is the longest project I've ever worked on. So it's been really fun for me. I hope for you too. And that number does not include the South Sewer meetings. So for those of you that were a part of that, it's been a long road. Chris, do you want to move to the territorial acknowledgement? And then there we go. So we're here today. Comox Valley Regional District respectfully acknowledges the land on which we gather is on the unceded traditional territory of the Comox First Nation, the traditional keepers of the land. We're honored to be here. I'd like to start the morning if we could, because it's been a bit of time since we met last. If we could just have a round of introductions, if you don't mind us taking the time to do that. And I thought we would start with the people that are online, because they deserve to be acknowledged. Good for you for being here. So maybe I can just ask you to volunteer and just tell us your name and who you're representing, if you don't mind. Mary, maybe we could start with you. I can see your name there.
Sure, I'm Mary Lang, Croteau Beach Area B representative. In this since 2014. So, yeah.
Sorry, Mary, if you wouldn't mind, we just had a volume control problem. Would you mind just repeating that for us?
Sure, Mary Lang, Area B, Croteau Beach, and I've been on this ride since 2014.
Super, thanks, Mary. Martin, do you want to go?
Yes, good morning. It's Martin Crilly, Town of Comox resident representative. This is only my second meeting and I'm looking forward to it. Thanks.
Awesome. Thank you. Caitlin?
Hi, everyone. I'm Caitlin Perchelski, and I'm here on behalf of the Comox Valley Conservation Partnership today.
Super. Thank you. Jenny?
Jenny Steele, originally a Curtis Road representative. I've been in and around issues with the Sewage Commission since I moved here in 2011. And I think, like Mary, I've been on this commission for a long time.
Thanks so much. Chris?
Yeah, thanks, Allison. I'm Chris Davidson, Director of Infrastructure and Environmental Engineering for the City of Courtenay, and I've also been to a few of these meetings now. Thank you.
Awesome. Thanks, Chris. Nico?
Morning, all. Nico, I am the Executive Director of the BC Shellfish Growers Association.
Thanks, Nico. And then I have a couple of others that are don't have their names. So maybe if you want to just volunteer and introduce yourself.
I'll go. My name is Lindsay Johnson. Sorry, I didn't realize my name is truncated in my Zoom profile. I represent the Ministry of Health Protection Branch from the perspective of regulation of on-site sewage systems. Thanks.
Awesome. Thanks. Anybody else that's on Zoom that isn't in the room?
Yeah, I can go. I'm Mark Hall, one of the representatives for Island Health. I'm the drinking water and land use consultant for Central/North Island.
Super. Thanks, Mark. Anybody else?
And yeah, good morning, Allison and everyone. It's Shelley Ashfield with the Town of Comox. I'm the Director of Operations.
Super. Thanks. Anybody else online? If not, let's start on this side. Let's start maybe with you, Len. Oh, I'm sorry, maybe John.
I am John Nacoma. I'm a City of Courtenay resident.
Len Polovich, City of Courtenay. I'm a newbie too.
Thank you.
Jim Elliott, resident rep.
We talk to you. Tabitha Donkers, Royston Area A representative.
Norm Prince, Crederick Subdivision representative.
Sheila Carey, Courtenay resident.
Will Cole Hamilton, Courtenay City Councillor and Chair of the Board at the CPRD.
I'm Michael Briggs, and I'm the branch assistant here helping assist the meeting. And just a reminder, if you guys have your mics on and they're red, you should turn them off when you're not speaking. Thanks.
Thanks, Michael.
Morning, everyone. Chris LaRose, Senior Manager of Water and Wastewater. Good to see you all. And I'll just introduce Mark Rutten, our General Manager of Engineering Services at the back there, and Zoe Berkey, our Senior Engineering Analyst, who's been had a lead role in this process. Over to you, Reid.
Morning, everybody. Good to see you all again. Reid Songton, Manager of Wastewater Services for the Regional District based out at the treatment plant.
Hello, this is my first time in person. So I'm Piero Galvano. I work for Carollo Engineers, and I was involved in the development of the site master plan.
Hello, Mike Deslitz with WSP Canada. I am preparing the liquid waste management plan for the CBRD.
Ken Newman, Royston resident and an alternate member of the advisory committee.
Kevin McPhail, a fairly recent addition for the town of Comox. Thank you.
Ian Monroe, alternate director for Area A.
Jake Keller, working with the Comox First Nation as the Director of Public Works.
It's Kevin Van Belzen with the town of Comox, and I just want to note with some fun that I was talking to Maureen here, and she said, "Remember when you signed up for 4 or 5 meetings in 2018?" I said, "Yep." Anyway, good morning.
Counselor at the town of Comox, and I've been on the Sewage Commission since 2011.
Mark Schaefer, Area B resident.
Great. Thanks great to have you all here. Did we miss anybody? Anybody come online? Okay, great. Perfect. We have a set of minutes from our last meeting, which is December 2nd. And any questions or queries? And if not, could we have a motion to adopt? Kevin, I always look to you. Okay, Ian or Ian. Thank you. Any discussion? All those in favor? Carried. Thank you. And now I'm going to turn it over to Chris.
Thank you, Allison. And good morning again, everyone. So welcome to the newer members, and a big thank you to the members that have been with us from the very beginning. 7 years since the start of this iteration of the project, but the predecessors to this, to a big piece of this planning process, even goes farther back to that, as a couple of our members online have noted. We've had various planning and processes underway for quite a bit longer than that. In fact, all the way back to 2003, when the existing force main along Wilmore Bluffs was found to be partially uncovered. So that right back then, there was the predecessor to this project that was initiated, and so it's been a long haul, and I think we're getting towards the conclusion here. So again, I really thank everybody's participation. We've got an agenda on the screen here that Allison, myself, and Piero and Mike will be walking through. I think Mark's got a bit of a presentation as well. So just briefly, so we've done the review of the minutes. I'll provide a bit of an update on the LWMP process and the work that we have underway, kind of laying out some of the pieces, and then Piero will give us our longest presentation of the day, which will be a review of the draft site master plan, which, as I'll touch on, is a key requirement by the province to inform our stage 3 plan, and also sets the program of work for our treatment plant for the coming decades. So there's that. Then Mike from WSP will be providing a overview of source control, our work on source control, which is another item that the province has asked that we address in our planning process. And then I'll give a bit of an update on the outfall. Again, the province has asked that we incorporate planning and a schedule for upgrades or replacement to that infrastructure within our planning process. Mark will tell us, give us an update on the Sewer Extension South update. And so for those of you that that aren't familiar with that piece, you know, the majority of those meetings that we mentioned, I think there was 11 meetings prior to submittal of the stage 1 and 2 plan. And so that was done with a sole focus on the core area, so Courtney and Comox. And then in parallel, it's starting later than the core LWMP. In parallel, there was a separate LWMP process happening in the south to examine how to manage wastewater in Royston and Union Bay. And then the culmination of that process was a decision to incorporate, kind of meld those two processes. And so we do have a member or two from the south who have now joined this TACPAC. So Mark will give us an update on that process. And then I'll end just with some next steps and what we'll be up to over the summer and when we'll come back together as a group and what we'll be talking about. And I do want to just ask that people interject at any point during any of these presentations. Just put your hand up virtually if you're on Zoom, or just put your hand up here in the room. And we'd rather take a pause and speak to your questions than make you wait until the end of what are some pretty long presentations. So yeah, please feel free to speak up and we'll resolve the question before we proceed.
Chris, just before you move from this, any questions about the agenda today? Anybody have any queries about where we're headed today? Okay, perfect.
Great, okay. So yeah, as I promised, I would, so this slide, I'll just provide a bit of an overview of where we've come from and what we're up to and where we're going. I understand, and I missed the last meeting, apologies for that, but I understand there was a bit of a catch up, just given the time that had passed and some of the new members that were participating. But I will just provide a brief summary. So way back in 2018, the liquid waste management planning process was initiated, and the focus was on developing a plan for the sewer conveyance project, and then setting treatment objectives for our wastewater treatment plant. And also a third component was looking at whether to add any additional resource recovery type projects or initiatives to our system. So as you've heard, we then subsequently went through an 11 meeting process, more than was originally conceived, just given the complexity and of the topics. And so that culminated and along the way, the decision was made to extract the conveyance project from the planning process. The reasons why a local government would dive into an LWMP are, they're numerous, but primarily it's a very well-structured consultative process. So it has a very well-established means of engaging. So this TACPAC this committee is one of those key tools, but also engagement with the public. And it at the end of the day, the plan, once approved, provides authorization for local governments to deliver the projects that are part of the planning, that are decided to be part of the planning process. And so partway through that process, the decision was made to extract the conveyance project. It was partly due to the extensive, kind of the rigorous process and how long it was taking, and the urgency with which the conveyance project had to be delivered. So yeah, the decision was made to pull that project out, and so it was authorized by a alternate approval process, I think back in 2021, I believe. And so the planning process continued, but with a focus on treatment. So the level of treatment at the plant and how we would achieve it. And so after 11 meetings, that stage 1 and 2 plan was submitted to the province in November 2022. And the ministry turned that around surprisingly quickly. I think it was just under 6 months, in May of 2023. And it's not actually an approval. They provide as is their practice, they provide a letter where they basically respond to the stage 1 and 2 plan. And in their response, they highlighted a number of pieces that they wanted to see included in the planning process moving forward and incorporated and addressed before the stage 3 plan is submitted. And so we'll walk you through some of those today and tell you when we'll be bringing others back. Let me just make sure. So yeah, so in the 2 years since the so yeah, almost just 2 years and a month since the ministry letter was received, we've been busy. We renewed or extended the contract to WSP to help guide development of the stage 3 process with Mike and his team. We undertook a very significant procurement process, which led to selection of Piero and the Corollo team to help advance the site master planning process and the Class B cost estimates for all of the upgrades that are required. And then we also engaged a process expert to help provide advice throughout that process for the treatment level at the plant. So yeah, it's been a busy 2 years. So in progress, we've got a number of studies and plans that are addressing those comments back from the province, which I'll touch on the next slide. And then the other key part to that is presenting those pieces to this group and speaking to any questions or concerns and hopefully moving forward with consensus. Jumping forward to the next slide. So a little more detail on those pieces that I was referring to. First of all, any questions about overall process before we dive into the details now? Okay, so yeah.
Is the stage 3, sorry, is the stage 3 report the final? That's when it goes in for approval?
Yes, yeah, that's right. And we'll touch on the timing for that later, but yes, that's exactly right. So the stage 1 and 2 are combined into that single process with response from the ministry. And then we do all this work together with this group to get it into the stage 3 plan, which is effectively the implementation plan for the outcome of the stage 1 and 2. And so just at a high level, we hope to have navigated the rest of this process, the analysis and the engagement with this group and with the public, with the KFN, and have that complete by the middle of next year, at which point our stage 3 plan will be ready for submittal to the province. And so yeah, the piece here, this is a list of the pieces that are underway, either nearing completion, which we'll be presenting today, or underway to be presented at a subsequent meeting. So the site master plan itself, which Piero will be presenting today, there was an executive summary of that document that was circulated in advance of this meeting. It's a very significant document, so Piero will be presenting it at a relatively high level today. And then we'll be circulating the detailed plan to you at some point this summer for review in advance of the next meeting, where we can have a more detailed discussion and there can be more informed questions from the group before that is finalized in the fall. There's the outfall planning component that I'll speak to later in the agenda, and Mike will be presenting on the source control planning piece. So that's today. And then looking ahead to the next meetings, we've got the site master plan full draft, which will be in the fall. The whole topic around inflow and infiltration, both Piero's presented already on kind of on how the peak flows strongly influenced by inflow and infiltration. I have influenced the planning process, but the province has asked us to work with our municipal partners to develop a more detailed plan about how we plan to, what the impact of I&I is on our system and how we plan to reduce it. we'll have some more information about resource recovery recommendations, how we, what we've looked at in terms of heat recovery and reclaimed water, and what we're thinking of incorporating into the plan. The environmental impact study, which is related to our outfall, and so we will be looking to increase the capacity of our plant and the discharge rate. So the EIS has to be revisited. So that'll be coming up soon. And then the phase 4 upgrade Class B cost estimate. So as I'll touch on a subsequent slide, as we navigate through this process, we'll be bringing more and more accurate cost estimates with more and more accuracy forward to help inform the discussion. And to make sure, because cost impacts to users is a key component of the planning process. The province, because of that, because the LWMP allows local governments to authorize the delivery of the projects, including the borrowing, the province really wants to see some rigorous engagement on the costs throughout the process. And so they've specified that those costs need to be communicated at a Class B cost estimate level, which means a fairly high level of accuracy, which can only be obtained through a fairly advanced level of design, about the 60% level. And so that's a major deliverable from Piero and his team to help feed into this process and give us that level of not quite certainty, but confidence in the level of estimates. And then the final piece is the establishment of a plan monitoring committee. So for those of you that have been really keen and loyal to this process, there's an opportunity potentially to continue indefinitely to make sure that we implement the plan as approved. So that's something that's inherent to the LWMP process. Yeah.
Chris, can we just talk a little bit about the expectations of the decisions that what the committee is being asked to do today? And that is, it's my understanding that what we're really hoping for is just have any concerns about the various components highlighted today, but not necessarily seeking, support, a motion of support. Is that correct?
Yeah, that's correct. Yeah, there's no decision or motion that we're looking for today. As you mentioned, Allison. So the first 3 components will be kind of reporting out on today. Sorry, the outfall, providing an update on outfall, reporting out on the source control piece, and an update on the site master plan. So yeah, no motions of support looking today, but more bringing you along in the process, working towards a future kind of motion of support. So yes, we're definitely very keen to hear any concerns or questions that you have to help support your own process towards eventual support of the planning process.
And are you hoping that in the fall, maybe we would come back together, and then you can see that this is the next step in the process, and the final step will be looking for a motion of support?
Yes, yeah. So I've got a slide towards the end as we come back after the technical discussions, where I'll get into that in a bit more detail. But I think, I think the kind of the formal approval of the plan is expected almost a year from now at our final meeting. But by the time we get there, it's a huge document with big attachments, huge attachments. So hence this multi-meeting process where we hope that you're really familiarizing yourself with the material and speaking up about any questions or concerns that you have, so that we don't get to the end of that process and it's just an overwhelming task for you to navigate that huge package of documents. So while the motion of support we'll be looking for at the end of the process, we hope that you're feeling free to bring your questions and concerns forward throughout the process, so that's not a insurmountable kind of overwhelming task to review and comment on it at the end of the day.
Everybody comfortable with that? Okay.
Okay. And I think this is my last slide. So this was many of you have seen this slide before. So it does a pretty good job of summarizing the technical pieces that are feeding into the LWMP process. So the top one, so I mentioned that we had engaged a process optimization expert. And so his name is Dr. Glenn Dagger. And we hired him to be part of the team in parallel with our team at WSP and Corolo to be the expert on to be an outside expert on the process piece. So he's ended up working very, very closely with Piero and Piero's team to help inform the direction that we've gone in for treatment level at the plant and how to achieve it. The vast majority of work has been done by Piero and his team, but Dr. Glenn Dagger has provided some valuable input. So he's provided input to the finalization of the site master plan, and therefore the detailed design or the phase 4 upgrades. In other words, how we plan to meet the level of treatment at the plant. And then that feeds into the Class B cost estimate, which Pierre and his team are well on their way to developing. And that feeds into the stage 3 report at different points. So the site master plan will be feeding in now and through the fall, and then the Class B cost estimate represents a very large piece of work. So that'll be coming in kind of next spring as kind of the final piece on that plan before we meet to review and provide final approval to that planning process. And then the pieces below just showing those other memos, some of which were shown on the previous slide, that'll be fed into the stage 3 report to help just round out our planning process, satisfy the provincial requirements in their letter of response to our plan. And then the final outcome is not just authorization for the projects, but also a new operational certificate for the plant. So that's another piece that'll be submitted in the stage 3 report. Would be a draft operational certificate, and then in their approval of the plan, hopefully the province will approve and formalize that operational certificate, in addition to the bordering approval for the upgrades at the plant. And this is just more, a little more detail of that process optimization piece, because it has represented a big piece of work, particularly or including on Reed and his team at the treatment plant. Dr. Dagger has driven or requested a number of trials and modifications to the treatment process over the last summer and into this summer to help provide data to Piero and his team to help kind of tweak and optimize the design moving forward, and that will be embedded in the planning process. Kevin.
Just out of curiosity, has the provincial mandate for, to build more housing had any impact on this plan at all?
Yeah, so a key piece or a key part of the planning process is developing kind of estimates for flows and loads. So that will need to be managed by the plant over the coming decades. So over the last couple of years since the provincial legislation kind of kicked off in November 2023, we've worked extensively with the municipalities to adjust regional growth projections, both within the municipalities and outside. So that it has definitely impacted in that way. So those estimates for population growth and thereby the wastewater that they generate have increased. So those have been incorporated. Yeah. 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 Okay, it from me. Unless anybody has any more questions about the background, I'll hand it over to Piero to, yeah.
Forgive me. I know we've talked about this long time ago. The Class B estimates, can you just remind me, like, what's the sort of confidence level on those? I can't remember.
Sure, yeah. So Class B is requires roughly a 60% level detail design. So a fairly advanced level of design, and it delivers about plus or minus 15%. So as I'll touch on later in the slide, as we navigate later in the slide deck, as we navigate the rest of this process, we'll be bringing forward kind of more and more advanced levels of accuracy for our cost estimates. So in the fall, we will bring forward Class DC, mostly Class C estimate, which would be plus or minus 30%, 40%. And then as Piero and his team continue to advance the detailed design, then it'll culminate in that Class B in the springtime. Yeah. Yeah. And then, yeah, so over to you, Piero. Yeah, and you press your button. Thanks.
Yeah, and ultimately the design, the more detail we get, the more unknowns that we can start to capture as line items in the cost estimate, the better the resolution is. And then we've got some slides here on the population projection. So the way I've structured this out, it's a long presentation, not long, but reasonably long. So I've broken it out into 6 sections, and I thought I've got a kind of a blank page in between. We can stop and have a stretch or just chat and take questions. But I'm also very open to taking questions as we move through this. So please interrupt. I think from my perspective, the point of this is to have a discussion, hear your feedback, any concerns. Like as stakeholders, there may be things that we also may have missed. So we want to hear that as well. So the first part of this is just the context of the plan, of the facility plan. So the treatment plant is owned by the regional district and services multiple jurisdictions. So the city of Courtenay, town of Comox, the Comox First Nation, and unincorporated areas of the CVRD, as well as the Department of National Defense. So here, the treated effluent is discharged into a pipe that runs along the coastline to Lasso Point, and then about 2.8 kilometers into the Salish Sea, and that's a submerged outfall. The treatment process, it's a secondary treatment plant. So the process is designed to take out what we're calling biological oxygen demand and total suspended solids. So these are the key parameters that you'll hear and see in the plan. And those are the criteria by which the effluent is assessed. And BOD and TSS, they just, when they get into the water column, deplete oxygen and just create problems for fish to survive. So the whole idea of, in a very high level, wastewater treatment is you settle as much as you can in the primary clarifier, whatever will settle. This is the most cost-effective and conventional approach. So settle as much as you can, and whatever's left over, the fine colloidal material, the stuff that doesn't settle or is dissolved, you biodegrade in the bioreactor using the microorganism essentially to break down that matter. You harvest the microorganisms, and that becomes your secondary sludge. So the bioreactor sludge and the sludge from primary clarifiers is managed by another set of processes. Equally important, the unsung heroes of wastewater treatment. So primary sludge and bioreactor sludge are first thickened, and then they go through some holding tanks, which we'll talk about later, and then dewatered. But the important part of this, the key takeaway here is that sludges from the wastewater treatment process are continuous. And so these processes need to be able to handle that continuous discharge or production sludge. It needs an unimpeded outlet is kind of that's the key objective. Otherwise, it will just pile up. So as what I think we've talked about the liquid waste management plan. So the site this master plan is being guided by the liquid waste management plan. So those are the guide rails for the work we're doing. And really, when we're done, it'll feed into the liquid waste management plan, and so ultimately becomes part of the works together with the municipal wastewater regulation, which is the government governing regulation for wastewater. So it's a really, in my view, an important document. We talked about the 3-stage process, and so I don't want to kind of belabor this, but just to point out that we're developing the site master plan to kind of the planning horizon that we've selected is to 2060, so it's 25 years. And the main objectives, and so these are kind of what I think that the main objectives, the key objectives are, is that service population is super important because it really drives the design criteria, and ultimately the whole point of this, the liquid waste management plan and the master plan, the overarching goal is to ensure that there's treatment capacity to service your projected population. So it's important. We want to be able to identify any existing capacity bottlenecks or end-of-life equipment and get those into the upgrade plan, and then also incorporate the goals recommended in liquid waste management plan, and ultimately develop that cost estimate and bundling up the scope of the phasing for these upgrades. So that's kind of what I've kind of at a high level. That's what I'm hoping will come out of this presentation. So that's the first part. Any questions or thoughts? Yeah.
Yeah. How has this plan been adjusted during the planning process? Because has this been going on for 7 or 8 years so far to get to this point? Like I imagine with new information and things have changed quite substantially. So does that the sort of planning end date, has that been adjusted at all?
That's a good point. So the liquid waste management plan has been going on for 7 years. We started the master plan last year, so we're taking we're basically updating. Part of the scope is to update all of the populations and work with the WSP because they need to finish up the stage 3 plan. So yes, it does. That is one of the, not complications, but it is one of the issues that we had to address, was kind of the changing kind of horizon, and specifically that Bill 44 that came down last year that eliminated the single housing in kind of pretty much in the province. So we need to readjust the population forecast to adjust for that, just to take an example. And then working with the process optimization experts. So it's all really the core work on the technical work has really just been in the last year.
Sorry, would you just mind putting your mic on, just so it's live and the people online can hear you?
Sorry about that. Yeah, I was just wondering if there's any more planned changes, or do you think it will be a bit more stable from now?
I do think that this is really the implementation. The hard part was stage 1 and 2. That was the long drawn out period. So here we're in the implementation plan. The master plan really is what's going to drive the implementation plan and finalizing the stage 3. Yeah.
Maybe I'll just add to that, Kieran, if you could expand on my response, but just relating to the site master plan, in addition to confirming the direction, it speaks to the timing. So if there were, to your point, if and when, not if, there are changes in how development occurs here in the valley, whether it be from additional legislation or just changes in market forces. It'll affect the timing of upgrades, not the direction.
That's a good point.
Yeah.
So the population projections are the kind of, we've tried to account for all the forces, all the population potential for the area and also for the new servicing. But yeah, ultimately we don't know where that, we can't say for certain that the population is going to grow based on the projections. The projections become our best guess and serve as the starting point for the planning. So if the population projections grow faster, what will happen is the phasing will just kind of be faster. So instead of the 2045, it might be 2040. So and that's part of the recommendation in the plan, is to continue to monitor the loading to the plant, because ultimately that reflects what's actually coming in terms of population, and adjust every 2 or 3 years. Okay, so this next section is on the population. Again, an important facet of the planning, because it drives all of the design criteria, and then ultimately the phasing of the upgrades. So the main goal is to ensure, estimate the population and ensure that there's sufficient capacity to meet that growth. And what we see in terms of growth, it's typically we see organic growth within the existing sewer area. People may be building another unit on their property, a basement suite, or subdividing. However, the infill that will be motivated by the new provincial regs, the Bill 44, needed to be accounted for. So that's removal of single-family housing and the ability to densify within what used to be a single-family lot, and of course the South Sewer extension. So we looked at so as part of the Bill 44, the requirement by the province was to for each of the local governments to develop a housing needs assessment, and so we used that as kind of to revise the population projections for the existing service area, and then use that as a basis for calculating wastewater loading. So these are the numbers, just to kind of put it graphically. So this is to question, how does it change? So the bold green line is the historical data, service population data, and then the last population projection from the LWMP is the dotted, the broken blue line, and the broken green line is our revised population projection. So it does increase the population projections a little bit, not significantly, but appreciably. And so from those population projections, then we can derive, so we've kind of, in the background, this table is basically all the numbers, which I don't want to talk to it, just to kind of, if we want to look at them. The idea is you take the population projections. In the background, we've taken all of the data that has been collected by the plant staff over the years, and try and kind of characterize the wastewater loading, and then apply that to the future population, as well as the loading, the organic loading, the BOD and TSS. We also looked at the variation in flows, because that becomes another important design feature. So we wanted to capture and project forward the wet weather component of specifically the wet weather component, but also peak day, peak month, those kind of characteristics which influence the design. So that's the population and design, kind of the front end, what goes into what we're using as the basis for sizing and design of facilities. So this next section, unless anybody has any questions, this next section is, so we've got the design criteria. Now we have to start developing options, a strategy for, so in the first few slides, we talked about the liquid train. So the wastewater comes in, settles in a primary clarifier, and the bioreactor is biodegraded. And then we have the sludge train. So I'll deal with each of those separately. So the first part is the mainstream process, the liquid train. How are we going to manage that? And specifically, how are we going to manage this the wet weather issue? So I have a few slides just to kind of you may have seen it already, but just to illustrate what is the challenge. So this first chart is just the loading, the daily loading to the plant. So it's during the summertime when there's no rainstorms. The groundwater is low. So this is what we typically see in a plant that doesn't have a wet weather issue. So it's very regular. We're creatures of habits, and so each day it's very predictable when the peak flow is going to occur, and at nighttime. So during the day you get the peak, and at nighttime you get the low flow. So very predictable pattern. When you have a wet weather issue, so this is what we would call what we're going to reference as the average dry weather flow. And if we then layer on top of that what actually what the treatment plant sees in the wintertime, so this is the dark blue line is what is measured at the plant, and I've plotted the dry weather flow on top of that, just to kind of give you a reference for how much the flow can vary during a wet weather event. So this was 2022 and 2023, and I think there might have been, my recollection is right, there was a snowmelt event, but in this case, the variability increases it's unpredictable is what it amounts to, and the variation flow can increase to more than 4 times the average dry weather flow. So it's a significant, because of that unpredictability, it becomes, and the large changes, it becomes hard to manage at the treatment plant. This is the same kind of data. So the flow data for 2023, but plotted over the entire year, just to give you a sense of when those high flows happen. But I've also plotted with dark blue line what the ministry, under the municipal wastewater regulation, defines as wet weather flow. So they define wet weather flow as anything more than 2 times average dry weather flow. So you can see that the wet weather flow issue is really confined, for the most part, to the fall and winter season, when you get the rainstorms coming through, groundwater comes up, leaks into the sewer system. So it's not graphically, it doesn't look like it's very much, and when we calculate that volume, it in fact isn't very much. So if we calculate over the last 5 years what the total volume, what the volume of that wet weather flow, so anything more than 2 times average dry weather flow, as a proportion of the total flow into the plant, over the last 5 years, it averages less than 2.5%. So it's really a very small, on a volume basis, the wet weather flow is very small in the whole scheme of things, which is good news. But so going back to our liquid train, this is the liquid train process, the primary clarifiers and secondary clarifiers. We have to size those based on the peak hourly flow, and recall, right, they can get during wet weather, they can get to more than 4 times the average dry weather flow. So we have to size those facilities based on the peak flow, and so that 2.5% of the flow, that 2.5% of the volume, really becomes the driver for upgrading these structures, and they're significant, right? And the other issue, the other kind of unfortunate thing is the primary clarifiers, secondary clarifiers, they're really designed for really stronger, like higher concentrations of solids. So their full potential is not being utilized. And they're significant structures. They're huge tanks, huge concrete tanks with complex piping and pumping associated with them. And so they're very costly to upgrade. So the expectation is that as the sewer service area expands, the assumption here is as it expands, that those peak flows are going to continue to increase, to continue to grow, and so one option is just continue to add clarifiers, primary clarifiers and secondary clarifiers to meet this this increase in flow, but it comes with a high cost, and that's been the problem with the past planning, right? Is that it really was kind of based on this approach of using the peak hourly flow, wet weather flow to size those facilities. So what kind of motivates the question that this motivated us to ask is there an alternative strategy that we can use that can be more cost effective while kind of meeting or exceeding the effluent quality, and so indeed there is. So we came up with two options. One, to compare against the base option, which is to continue to just upgrade as per the flow coming into the plant. So the first option that we wanted to investigate was what we're calling chemically enhanced primary treatment. And we'll describe them in more detail in subsequent slides. And then the second option is to add, do the chemically enhanced primary treatment, but also to add a wet weather treatment component. So something that just treats that wet weather flow, that diluted wastewater. And so we wanted to see, okay, what impacts do these options have on cash flow? So we have these phasing. Does it change the phasing? How does the overall cost compare against the baseline option?
Sorry,
Yeah,
Kevin?
Yeah.
Sorry. Way back when, I believe you guys used the term INI, like ingress and infiltration. I know that was one of the issues, cross connects and, the extra load getting into the system that was never intended.
Yeah.
Is there any portion of this that looks like that? Or is there any cost benefit to doing that work?
So that is what we're talking about, is the INI. So yeah.
I guess what I saw there, and perhaps incorrectly, this is more of a treatment far end, not stopping from getting in to begin with.
That's a very
just a question.
So you make a very good point. So we're talking about managing the wet weather at the plant, but none of this would be required if you could stop the INI. Yeah, and we can talk about I'm looking forward to hearing the wet weather reduction, because it's also complicated and time consuming. So it's trying to balance the different objectives. So and when we get to the end, we can talk about with our recommended option. Part of the benefit is that it gives you flexibility, that you're not building infrastructure that later you don't need because you reduced INI, that it will continue to benefit you even with the reduction in INI.
Peter, it's Martin calling in from Comox. For stormwater, we talk about detention ponds for clean water. For liquid waste, we don't seem to talk about detaining that in order to smooth the flow. Why don't we just have many big swimming pools of sewage waiting to be treated to deal with the peak flows?
So ultimately, I can kind of skip back up to this. It comes out in this flow data. So if you look at so if we have these big ponds that we're equalizing in effect the flow, how long do we retain that volume? So in theory, we would want to draw down the volume over 24 hours, but maybe you could size a facility that could be a multi-day, because storms don't happen in 24 hours. they can occur over days. So the amount of volume that you would need to store, I can't see the numbers because it's hidden by the, let's see if I can move, but so if you look at the maximum day load, it's 40,000 cubic meters, which is an enormous volume it's a huge basin to have to build. And then it's kind of dilute wastewater. Would you want that to be open? So you probably want it covered. So the cost to kind of equalize, to create these basins is, I think, yeah, if you had the land and the land was very cheap, but what I see is that you would need several hectares of land to create the storage required.
Here, I'll just speak to the specific question about the INI and whether the plan addresses doing something about that. So one of the pieces the province did ask us to come back in the stage 3 process with more detail about was exactly to answer that question. You know, what will be done to reduce INI. So to the first and second stage, we did work with the municipalities to include some detail about what they've done and what they plan to do to reduce INI. And so the province was not satisfied with that level of detail. So we're working with both teams to flesh out a more in-depth analysis and then work with the municipalities to come up with a more detailed plan about how to reduce INI. But I think just to reiterate Piero's response, you know, that the plan for the facility is kind of back to my answer about you know, whether differential rates of population growth materialize. You know, if we're really successful in working together to reduce INI, that could help to reduce or delay the phases, the future phases of upgrades. If we're not, you know, it'll adjust the timing, but not the approach to how the wastewater is treated.
Yeah.
Martin, did you have a follow-up question?
Thanks for the opportunity. I just I'm trying to envisage it. So if we can do, sorry, don't have my video on. I'll turn it on. Seems to me the volumes involved in detaining stormwater would be even greater than the volumes involved in detaining liquid waste. So I'm trying to reconcile. I mean, the flow of stormwater is much greater than the flow of liquid waste, right? So if we're detaining stormwater, why are we doing that? Why don't we have lots of little detention ponds across the region in small areas, usable areas? It doesn't have to be one huge pond, and control the flow of liquid waste into the plant much further back in the system. Why don't we do that?
It's a good question, but I think the reason for the larger volume that would be necessary for wastewater is that you have a far more limited outlet capacity, and that could be why. So with a stormwater pond, you have a bit more flexibility, and you're limited by the downstream conveyance capacity of the system, and not necessarily by the treatment plant capacity.
It's also economies of scale to your earlier point, Piero. Wastewater is very different than stormwater. Stormwater ponds can be open and they look like a pond. Wastewater attenuation facilities would have to be enclosed, covered, pumped, and so the cost of adding, you know, dozens of those throughout the system would be significantly more than adding the same volume of on-site equalization at the treatment plant.
We have a couple of hands up, Jenny and then maybe Kevin. So Jenny, do you want to go ahead first? Oh, and then Jim.
Yeah, I was just going to point out that there is the problem of odor. The current plant is in the middle of a residential area. And so anything that goes on up there has got to consider the neighbors and odor control. So I put my hand up when the suggestion was to put it all into a big pond, and that certainly wouldn't fly, I don't think, in the neighborhood. And I guess I'll keep my other question till later. That's fine.
Thanks. Ken, I think you're next.
Yeah, my question relates to the reality of climate change and really extreme events. And a while ago, just for fun, I looked at the rainfall data from the base in Comox. And of course, they have great data going all the way back to 1943. And the average rainfall in December is about 0.6 of a centimeter. The heaviest rainfall ever recorded in a 24-hour period is 11 centimeters. That's 4.5 inches of rain. And that's probably close to a 100-year event. What would a 100-year event do to you?
At the start of this, we did try and approach the wet weather on a return period basis. So we looked at we do have a couple models that we developed, and then ultimately sort of went with the conventional approach of estimating future wet weather. So my recollection is that there was in the data record. So in the data that we analyzed, there was, based on this Gumbel distribution, we did see a 100-year return period. So it does. What I saw was that the data that we projected it might even meet the 200-year return period criteria that we calculated for wet weather. So I agree, and I think with regards to climate change, I believe that we're seeing that in the data already. So we're seeing very peaky storms. So yeah, it's something we're very conscious of, and I'm confident that the system that we're presenting ultimately is a resilient system that can accommodate much peakier flows. This wet weather strategy, as opposed to relying on concrete tanks. And, yeah, but it's a good point.
Yeah. I guess my only sort of closing comment on that would be you consider what happened to the Coquihalla Highway, and that really was a totally unexpected event, I think, as far as British Columbia was concerned, and it's a bit scary.
Thanks, Ken. Jim.
Yeah, there's been a fair bit of discussion about stormwater. It's my understanding that it's not a combined system. So we're really talking about inflow and infiltration. I'm not sure if everybody's clear on that. So it's not like we're collecting the stormwater and putting it through the treatment plant. It's what's leaking into the system or being pumped into the system. And as my favorite thing is, I do believe a lot of the inflow is caused by personal sump pumps in people's houses in the basements. So I think that is an area that could be looked at. It's a fairly easy calculation that I've actually done in the past, how much a sump pump that was running in somebody's basement could contribute to the sewage flow. And it might be an area that needs to also be looked at. The other comment was made about population growth allowing for more I&I into the system. And I'm just curious why new systems would be contributing any I&I to the existing system.
We had that same discussion, so it's conservative, and the thinking is that we don't necessarily know, and that could be part of what comes out of the I&I study, the reduction study, is to really get at where that I&I is coming from. Is it from high groundwater that's leaking into the sewer system? So, and then the other feature of all of this is that a lot of the population is going to be densification, right? So we can't we couldn't easily extract, kind of peel away what was going to be new and where it was going to go, and estimating the I&I in a meaningful way. So we looked at 2 or 3 different strategies, but ultimately settled on the approach because it was more conservative.
I think it's obvious that I source control has got to play a major role in this whole process. And I would really hope, I know the I hasn't really changed much in the last 40 years in terms of the total relationship of I to average dry weather. So I think it's really time that that's taken a very hard look at, and at least try to find some of the low hanging fruit that's out there for I. It doesn't have to be super complicated. There are a number of methodologies of very easy of lifting manhole covers in a big rainstorm and seeing where the level is, and that'll help to narrow down where it's coming from. So anyway, I hope that I does form a big part of this plan, I control.
I take it we're going to come back to that later in the day. Is that right?
Not today,
Not
but
today.
at the next meeting, we'll have more detail about that. And I fully agree with you, Jim, and the province does too. So they, in their response to our stage 1 and 2 plan, they firmly, required us to speak in much more detail to this topic in the stage 3 plan and what we're going to be doing to help reduce those numbers. So yeah, so we do have Mike has put a lot of work into a memo that we'll be working to finalize and engaging with the municipalities, and then eventually bringing that back through this group to let you know what commitments will be made in the planning process. But and another piece to that is part of the site master planning process does include an analysis of how the schedule of changes or program of work at the plant would be affected by different scenarios of success with reducing I. So that'll be used to help inform decision makers in terms of setting those commitments that the province wants to see. Yeah.
Jake?
Do we know roughly what proportion I is contributing to the maximum load, like when compared to population growth?
Well, correct me if I'm wrong, Piero, but the vast majority of that increase, certainly everything above 2 times average dry weather flow, but almost everything above the average dry weather flow is some form of I. So just for those of you that aren't familiar with it, there are a number of different sources of I. So to Jim's point, a big one is likely sump pumps in basements. So it's just a convenient place to discharge. If you have a problem with groundwater in your ground floor, what's your closest point of discharge? I mean, you'd have to go through the foundation to get to your perimeter drain, assuming your perimeter drain is attached to the road. That's easier to discharge it into a sanitary line that's crossing your crawl space. So there's probably a lot of that. There's a lot of downspouts from roofs that are connected to mistakenly or otherwise connected to the sanitary system, because the elevations don't match up well for a connection to the street storm line. And then there's the leakage into the pipes and the collection pipes and the manhole penetrations where the pipes penetrate the manhole. And then there's surface flow that during really big events that flows over the streets and dribbles down into the top of the manhole, the sanitary manhole. So there's lots of different sources of I. But yeah, there's definitely time-tested ways to work to identify and resolve. So we're also looking at other jurisdictions and how they've taken strides and made big progress on reducing I. So that'll be woven into our approach here as well.
Yeah, well, good questions. Yeah. So back to the mainstream liquid train process upgrade. So first we have the kind of the conventional approach of kind of just upgrading the primary clarifiers, secondary clarifiers, and then the chemically enhanced primary treatment is really just adding a coagulant, which disrupts the charges on the particles, those small particles, causes them to agglomerate and settle faster. So what we're doing is with the coagulant is increasing the capacity of the primary clarifier. And we expect to see with coagulant polymer approximately, or at least 20% increase in capacity. And this photo on the right just tells the story. So the left-hand column is would be the wastewater coming in, and you add the coagulant, and it causes the disruption, agglomeration of particles, and quick settling of the solids. So the assumption here is that you really only need it for that 2.5% of the flow. So when the peak flow coming into the plant, when it's measured to be above 2 times average dry weather flow, then this polymer coagulant pump would come on and feed the primary clarifiers. So pretty straightforward. Option 2, we assume that that we'd have the high rate primary clarification, the coagulant, but during wet weather flows, during those peak flows, we would have a diversion. So we would take everything above 2 times average dry weather flow and pipe it to the end of the secondary clarifier, blend it with the secondary effluent, and then filter everything. So you'd have this tertiary filter that would kind of provide the treatment that would allow you to meet permit. So the benefit of this is you're truncating that flow. So that peak flow, which is really driving the secondary clarifier upgrade, if you bypass it around to your wet weather treatment, then you can you don't have to upgrade the secondary clarifier as soon as you need to, and you're only doing it during periods of dilute wastewater. Yes.
Thanks, Jenny. You have a question? Jenny, we can't hear you for some reason. You're muted. We'll come back to you when you can unmute, maybe. Do you want to just carry on? And oh, there she is.
Yeah, I'm on
There
mute.
you are.
I'm sorry, excuse me. It's been a while since I've been in a Zoom meeting. Okay, right now, after the primary clarifiers is a large holding pond. I don't know, a tank. You can't call it a tank. It's just a big, huge holding pond, which is there to take effluent coming out of the primary clarifiers in periods of peak time. Do these plans get rid of that?
That's a very good observation. So there's an equalization pond.
That's it. That's the name of it. Sorry, I forgot the name. Yeah.
There's an equalization basin that is kind of on the other side of the primary clarifiers, and it was designed for this peak wet weather flow attenuation. So the challenge is that it's impractical to operate as a peak wet weather flow facility because it's open. So there's a lot of potential for odors, and during you get the stuff from the bits from the trees are coming into the basin. So
okay, so that was a $2 million expenditure that didn't quite work out.
What it needs is a cover for it to be effective, and that also is very complicated. But where that facility, in the plan, what we propose to do is there's another feature so we talked about the dry weather flow having this regular kind of pattern. If you can even out those bumps and create a more even flow into the bioreactor, you get a much better performance, treatment performance. So that was another objective of this plan, was to improve and I didn't get into this because it's another. It would be it's a little bit more complicated, but it's another important feature of the plan that we'll document. So the bioreactor has had a history of performance issues because of the wet weather. So the sludge settles very poorly. So one of the features. So we're going to, as part of the phase 4 upgrades, upgrade the aeration system. And that's part of what Glenn Dagger, the process expert, was in to do, was to try and come up with ways to improve that, the performance of the bioreactor. Equalization, diurnal equalization would also improve performance. So it's not a throwaway, but it is a future consideration, yes.
Okay, but.
Thanks, Piero. Just, sorry, Jenny, I just wanted to answer or speak to your previous point there. So the EQ basin was actually built to help us navigate peak flows and when they combine with high tides for the outfall capacity.
Right.
Until we upgrade that infrastructure. So Piero has been talking about diurnal equalization, so more to help smooth out the flows through the treatment process. So that's a different purpose. And what his point, just to reiterate his point, the conclusion was that that basin is not appropriate to help with that much more frequent use that would be inherent to using that basin for diurnal equalization.
Okay,
But it remains a critical part of our risk mitigation of the plant overflow during peak rain events and when they coincide with high tides.
Okay, so that would remain, and you'd put in some kind of other equalization tank, which was talked about a long time ago, an equalization tank, a concrete tank. So is that what you're talking about in terms of equalization?
So yeah, that is one option, is for diurnal equalization to help with the performance of the bioreactor, is to incorporate a concrete tank. That's one option.
Okay, fair enough. Thank you.
Ken?
Yeah, I guess my question in the final analysis, with this wet weather option 2, how does that affect the quality of the biological quality of the final effluent that's discharged into the Salish Sea?
Sorry, the quality of these options.
Yes.
The filter.
Yes.
Good question, and we have some slides too.
Okay.
We had the same question. So with this option, it's a novel approach. It's not unconventional. There are other treatment plants that use this particular approach, and in the next slide we have a cutaway of a tertiary filter that's designed specifically for this blended, because the other reality is that the wet weather issue that the Comox Valley treatment plant experiences is not uncommon. There are a lot of treatment plants around North America that because they were designed, the collection systems were originally designed as one pipe, or they have the same kind of leaky collection system. They're having to treat a lot of dilute wastewater during storm events. So this product has been around not that long, maybe 10 years, and is a tertiary filter that's designed specifically for this kind of wet weather, blended wet weather, dilute wastewater filtration. The effective pore size is 5 microns, super fine, and achieves very good TSS and BOD removal. So the plots on the right kind of are averages of the removal rates that this system sees, and these are averages of dozens of pilot and full scale tests. So for TSS removal, you're looking at greater than 80% removal, and BOD kind of a little bit more than 60% removal. So how does this affect the quality effluent? So the quality effluent on average, so if you average it over the entire year, the quality effluent is much better, because only that 2.5% of the volume is going to be bypassed and blended and then filtered. But for the remaining part of the year, your secondary effluent is being filtered. So on average, the volume, averaged over the year, the quality of the effluent is much better. Yeah. So in order to kind of quantify that it will actually work, so it treats the entire flow much better on an average annual basis, the quality. But this was kind of, I put these up just to kind of reinforce that that we had to demonstrate that this would work. And we had to kind of also convince ourselves that it was the right solution. So we set up a process model to assess the wet weather flow and kind of the treatment capacity of the system, and then the blending, and then accounting for the filtration. What would the final effluent look like? So we designed based on the existing flow into the plant. We designed some storms that together with the dry weather flow produce these this kind of worst case month that has multiple instances of 4 times average dry weather flow on a peak hourly basis, and peak day flows that are 3 times average day flow, and sustained flows that are above the 2 times average dry weather flow. So the whole point of this was to try and kind of come up with some worst case scenario and run it through the model to see what effect it would have on the effluent. And so these graphs just kind of illustrate the outcome of the model. So on a monthly basis, the monthly average is well below the 25 milligrams per liter that is specified for BOD and TSS in the permit, as well as the max day of 45. So it meets the effluent objectives without too much trouble. Is kind of so this gives us kind of reassurance that this is a good solution and would help to solve some of the wet weather issues while providing an opportunity to do a better job, like to get that quality, increased quality over the remaining part of the year with the tertiary filtration.
Have another question from Jim?
Yeah, and I would imagine that because it's very dilute, from the stormwater or the I&I, it's already fairly low coming in.
Yes.
But also without bypassing the treatment trains, it's going to wash out a lot of the solids, of course, which is going to really impact the effluent. So there's that aspect.
That's a good point. And that's the reason why those secondary clarifiers need to be sized for peak flows, is to prevent the washout. So the bioreactor is this mixture, like these flocks that are basically the bugs growing in the bioreactor. And if you get these big surges of flows, they get washed out of the bioreactor. And if the secondary clarifier becomes a mechanism for retaining all of that biological sludge, which is doing the treatment. So if your secondary clarifier is undersized, then that just gets washed out into the outlet. It's an excellent point.
Sorry, John?
So you said those big overflow holding tanks don't have covers, and that's a problem. So is putting covers in those part of this process?
We did look at covers for the equalization basin, but it wasn't going to be practical without some intermediate structure. So that is a feature of all this that is ongoing. How to best manage. I think what we've come to is that basin works well as kind of a last resort when the tide levels are very high, and you need some emergency equalization because they're uncovered and you use them once a year. Yeah. So just under worst case scenario. So that seems tolerable, given that the complication, the cost of adding the cover. So or creating a structure over that basin that would allow to keep all the material out from the trees, but also to contain the odors. So we have looked at it and have settled on this approach of, in the future, adding some kind of equalization, like a concrete tank that would provide for the diurnal equalization, which requires far less volume, and retaining that basin for emergency.
Okay. To Jim's point earlier of just catching the low-hanging fruit, has the CBRD done much monitoring on sewage outflows from different areas around town, just different suburbs, or sort of identifying where some of these peak flows might be
It's
coming from?
So yeah, all flows into our treatment plant are pumped. So we've got 6 pump stations now. So we track the volumes coming out of those stations. So that provides some breakdown about where we're seeing them. But they are fairly consistent. I mean, the two older, like the downtown cores of Courtney and Comox have the highest values, we understand. But otherwise, it's fairly consistent between the communities. But yeah, so those 6 stations do provide the opportunity to compare flows. Yeah, but other than that, there's no meters in place other than the pump, the pump times and run times from the stations, which and flow meters at the inlets to the stations. Yeah.
So the next part of this assessment was to use our population projections and then lay out the timing for the 3 options, and then do a cash flow analysis to see if there's any benefit to one of the 3 options. So these next 3 slides are really just to graphically lay out for each of the 3 options what are the requirements in terms of upgrade. So under the baseline option, and this is kind of reflected in some of the previous planning, in order to meet the 2060 kind of surface population loading, you're looking at 6 primary clarifiers, 6 secondary clarifiers, and then 4 bioreactors. So that's kind of what we want to compare these other 2 options to. So with option 1, with the chemically enhanced primary treatment, right, we can defer one of those primary clarifiers given the additional capacity. And so for 2060 servicing, we only need 5 primary clarifiers, but we still need the 6 secondary clarifiers because we're not doing anything to bypass the flows around the biological system. So under this option 2 with the chemically enhanced treatment and the tertiary filter, it reduces the requirement for secondary clarifiers to 4. So you're saving 2 within that kind of the timeline, the planning timeline. So, ultimately, depending on if your population continues to grow, then yeah, there'll be a need for more primary clarifiers. But it does mean that you don't have to implement these things nearly as quickly. Yeah. So then the last question here is, okay, what is the value, the cash flow, and the value kind of on a if we assess the entire flow or the entire cost. Yeah. Sir.
Maybe just one comment to add to Piero. Forgive me if you have this on a subsequent slide, but I just wanted to highlight while you had this on the slide that that another benefit to this option, which should be evident, is that this option provides for significant growth beyond 2060 on this site, in a way that the baseline doesn't. We're almost with those 2 additional secondary clarifiers and additional bioreactor and additional primary clarifier, we're starting to bump up against the footprint capacity of that facility. But by taking this route, we leave ourselves, decades, beyond that 2060 horizon, which is a key benefit too.
This figure is just documents the cash flow. So it just kind of highlights, just indicates, kind of reflects what the last 3 slides with the staging. So when each of the facilities are required, and then their cost. So when we do the net present value for each of these 3 cash flows, the wet weather treatment option with the chemically enhanced primary treatment has the lowest cost by almost $20 million and less than the baseline. So even though your upfront costs are a little higher because you have to implement the tertiary filter, the savings that you get down the road in 2040 and 2060 kind of gives the savings there more than offset the initial cost. So the summary of all this analysis is that by implementing kind of chemically enhanced primary treatment, it's a relatively low cost way. It's just some pumps and some chemicals, some coagulant. It defers primary clarifier upgrades, so it has some significant savings. And then by implementing an effluent filter and blending with mainstream flow, you can manage the peak wet weather flows very efficiently. So by doing this kind of diversion, this peak wet weather diversion to the secondary filters, you're taking the load off, the hydraulic load off the secondary clarifiers, and you're pushing out the upgrades there. And then kind of what we kind of tried to highlight is that tertiary filtration, the way we've proposed it, would be for the entire stream, the entire secondary effluent, so it would operate year round. So you're getting much cleaner effluent, and that has a benefit on the receiving environment, but will be make for more efficient UV disinfection. And also because the ministry, and this is kind of a subsequent section on the reclaimed water, by implementing the tertiary filter under the municipal wastewater regulation, just gives you a broader range of uses for reclaimed water reuse, for effluent reuse.
Question, Ian?
I appreciate the analysis and the cost effectiveness. I'm just wondering if there's any implications to a mill rate, tax rate, by advancing the capital costs, if you will, right? Like where there's those upfront filter costs that come in. Does that change how the rates get calculated, or does it all come out in the wash when you start financing and doing debentures and those sorts of things?
No, a shift or front ending of capital will have an effect on rates. So as we communicated earlier, we have at this point we have fairly high level cost estimates. So for comparative basis, to inform Piero's work, as we continue to navigate through the process, we'll have higher and higher accuracy. So while there's a slight front ending of capital, and that will have a small impact on taxation. It's not very significant.
So then as a follow-up, if there is that initial slight increase in taxes up front because there's savings later, does that mean there would be anticipated tax decreases later?
Avoided further increases. Yeah, lower increases as all the other upwards pressures on rates, inflation, etc. So yeah, it would be expected to result in lower than expected increases in the future. Yeah.
Okay, yeah.
Yes, sorry, just to go back to the point of monitoring, like I'm just really liking what Jim was sort of talking about, increasing the amount that is coming into the total system. Has there ever been like a widespread monitoring program sort of thought about or proposed in terms of this? Because I wonder if the cost effectiveness of each house, say, mainly require a $10,000 upgrade, like would it be worth putting that energy and that money into the other end of the system? Just curious if that's been thrown around or discussed, because I know there's a lot of really great monitoring systems and that sort of thing for widespread cities that we could do. So yeah, curious.
No, absolutely. I mean, those are the types of strategies that we definitely see being part of a I&I reduction strategy regionally. But there's no scenario where that materializes, where we get the significant enough decreases in I&I on a tight enough time frame to avoid having to initiate or kind of set the first phases of the upgrades in this direction fast enough. So as we talked about earlier, the province is going to hold us to much more significant commitments to I&I reduction, and we've got that ball in motion with the analysis required, both from Piero and Mike's team, to support those discussions with the municipal staff. But it doesn't avoid the need to upgrade the facility. If we're very successful or moderately successful or not very successful in I&I, that will just impact the timing of those future additional tankages that are required.
And what sort of timeframes is that on? Is that like a monitoring program put in place by 2035, or is there any set dates?
So as I highlighted, we're doing the work to present the case to our municipal partners. That'll be done this summer, and then we'll be reporting back with the memos from both consulting teams and the outcome of the engagement with municipalities, presenting the proposed approach for those commitments that will be embedded in the plan. So that'll be the fall or winter of next year. So I don't have the answer to the question now because that engagement hasn't occurred yet.
Yeah, thanks for that. And it's just my first time here, so apologies for all the questions on this, but thanks for your time.
No, I really appreciate it. This is a really important topic. Thanks, Jake.
Chris, just on that topic, you said earlier that you anticipate that the I&I is in the municipal systems as opposed to in the regional system. Is correct? Like that. So there's this jurisdictional split in this, right?
Absolutely. Yeah. The most part, that's true. That being said, the region did add 2 trunk lines in 2018 to 2020, which are gravity. So there's likely some minor I&I on those trunk lines, but yeah, the vast majority of the I&I does come into the system through gravity collection systems, of which 98% of those fall within the municipal bounds. The rest of the regional infrastructure is force mains, which are pressurized and not susceptible to direct inflow and infiltration. So it is. You're absolutely right. It is a jurisdictional piece. I mean, the CBRD does not have direct control over 98% of the I&I that's coming into the system. So that's why I was focusing on the importance of that engagement with the municipalities, because they're the ones that will have to do the lion's share of the work to further advance reductions in I&I. And so what our part is to do the analysis, to demonstrate, to show them, to help them build the business case for the investments required to help reduce those I&I flows. Yeah. Thanks for that prompt.
Yeah, thanks. Just for Jake, you said it's the first time here, so understanding that is a kind of a key part of this, understanding who is responsible for the collection systems.
Yeah, that really helps to know the boundaries. I can sort of see, the answers to some of that. So thank you.
Jenny?
Quickie question. The tertiary filtration, does that need odor control? Any of that kind of piece that you're adding? Would the odor control?
It doesn't normally need odor control.
It doesn't normally?
No, the odor typically at the plant, bioreactor, primary clarifier, like the most odorous process is already covered by the foul air treatment, and the tertiary treatment. It's really just the filters are submerged, and it's just the effluent, the treated effluent that is moving through that process. So the sludge is very thin that are vacuumed off the disc. So we wouldn't consider that.
Okay, but I thought that tertiary in peak flows, basically you'd be pumping into the tertiary without going through the bioreactors, correct?
Getting that. Okay, that's a good point.
I can speak to.
So basically, I mean, in normal days, yeah, I can see that it wouldn't smell because it's been through the bioreactors. But in times of peak flow, I thought the plan was that you would go straight from basically the primary clarifiers and bypass the bioreactors.
So that would be for flow, for the portion of the flow over 2 times the average dry weather flow.
Correct.
So
Correct.
the bulk of the flow would still be passing through the treatment process that Piero mentioned. That being said, to put your mind at ease, Jenny, we are working to finalize the Good Neighbor Agreement. That's been in the works for a number of years now, but has been waiting the completion of this work and follow-up odor monitoring that's being done this year. So that the key outcome from that the key parameter in that Good Neighbor Agreement is the odor limit, operational and design for the facility. So that is, if through follow-up odor monitoring of that facility, it's determined that it is contributing or threatening our ability to comply with that odor limit, then we will take action.
Yeah, but we don't want to end up in the situation where you put this in and now the neighborhood is suffering with the problems. Just out of curiosity, what are the odor performance expectations? Other jurisdictions, as you know, like Vancouver, have a zero odor at the boundary expectation, and I know we never got finished the Good Neighbor Agreement, and I have no idea what you're planning on putting in it at this point. Do you have a sense? No, please.
I don't no, I don't have a number that I can share right now, but we'll be, once we've completed the follow-up odor monitoring sampling this summer, then we'll be bringing forward a proposed Good Neighbor Agreement for the community, and there'll be an opportunity to engage and for the community to provide feedback at that point, Jenny.
Okay, fair enough.
Yeah, but the outcome from that process will help guide the final design for the upgrades at the facility. So we will reassess, and should the combination of the Good Neighbor Agreement odor limit, where we land on that, in combination with an assessment of the proposed infrastructure, conclude that we wouldn't be able to meet it without some type of odor control at that facility, then we would navigate that.
Well, I'm just wondering, do we need the Good Neighbor Agreement anymore? Given that we're going to have an operational certificate that I assume will contain some talk about odor controls, as I understand everybody else's operational certificates do include odor issues. I don't know, do we need that, or?
I don't, my understanding is that the operational certificate does not speak to odor, but Piero or Mike, do you have
my reading is it does not have to, but most do. Because and they do spell out certain things like zero odor at the boundary, how often you follow up.
Then maybe we'll follow up on that, Jenny, and if that's the case, if some jurisdictions are embedding odor performance in with their operational certificate, then we certainly
they absolutely have, because a couple of years ago I read a couple of them, and there's odor controls right in there.
Yeah, you're right. That could be an alternative approach to
the Good Neighbor Agreement.
Yeah, thank you for raising that, Jenny.
Okay.
Yeah, I've seen them as well. And the criteria vary in terms of what's in the permit. And I'll bring up the kind of, just to kind of check. I'll convey your concern about odors from the tertiary filter to the designers, just to.
Thank you.
It's covered up.
Thanks, Piero. See Mark.
Just a question, you have UV up there. Is there currently UV at the plant up and running? And don't you think it should be one of the first things put in there?
Yeah, that's a good point. So that the recommendation to incorporate UV came out of the liquid waste management plan. So it's I didn't cover it off because it's already one of the, like, the headworks is another one. The screening facilities is kind of something that is it needs to go in, the existing system needs to be replaced, and then UV disinfection. And the UV disinfection, the rationale for putting that in is to do disinfection, but kill the coliforms and kind of just improve the quality effluent because of the shellfish harvest.
So, yeah, so just to reiterate, it's part of the baseline. So there's no scenario where that does not get implemented. Yeah, it was a commitment made by the commission back in 2018, I believe. Yeah,
that's a good point.
Yeah.
How are we doing for time on your presentation?
So I have a few more sections. I can speed it up or slow it
No,
down.
we have half an hour. You have
Okay,
half
good.
an hour. I
Okay.
just
Okay, I think this format of taking questions as we go. So I have two more sections. The solids management is, I think it's worth just a few slides just to cover this off. Remember, this is the we got the treatment is always producing sludges. We need an outlet for it, otherwise it piles up. So we needed to kind of consider that within. Now we had developed all the design criteria, population loading. All of that loading is going to increase the amount of sludge coming out of the plant. We also took a look at the redundancy for each of the processes, just to ensure that that we're balancing risk and cost, and because the municipal wastewater regulation doesn't specifically address redundancy on the solids management side. They do. The regulation does specify what kind of redundancy, minimum redundancy that you need to have on the liquid stream part. So that was something we need to do. And so I just wanted to, there's just 2 or 3 slides. I just wanted to, I guess, convey some of the key features in this process that then get translated into the plan. We have gravity thickeners that thicken the primary sludge. They're separate processes because the thickening characteristics are different for the primary sludge and bioreactor sludge. And then from there, it gets dewatered ultimately with the centrifuges. But centrifuges operate kind of during the day, during the workday, and sludge is continuous. So we need something to address that. And so we have in the process thickened sludge and TWAS, or thickened waste activated sludge holding tanks. So those tanks fill up at night and on the weekend, so that to accommodate the centrifuges being operated, somebody needs to be there. So operation is a daytime, a weekday operation. So that storage is important. But ultimately, it's the centrifuges that dewater that slurry and kind of convert it into a sludge that then can be transported to the compost facility. And so the centrifuges, the way that the centrifuges are designed, you have redundancy. So there are 2 centrifuges, and they can be, usually it's just 1 centrifuge that's operated to have that redundancy, but they can be, I just wanted to point out, in order to get more capacity, you can run the centrifuges for longer if needed. They're 20 years old, so they're getting up there in terms of age, but function well. The current consideration is to defer those, replace those replace the centrifuges in 2040. So that means running them for an extra 15 years. And that would mean increasing the runtime. So adding either shifts on the weekend or longer shifts during the weekday. But regardless, as part of phase 4, we're proposing that so the ventilation in the centrifuge room needs to be improved, and that kind of will also help with the reliability of the existing system. So hydrogen sulfide it corrodes metal. So getting that hydrogen sulfide out of the room is going to help with the electrical controls and the reliability of electrical systems, but also safer for staff, just a better working conditions. And then, so that's a 2040 upgrade. And then in 2045, the projections suggest that that the plant is going to need upgrades to gravity thickener and the like both thickeners, as well as additional thickened sludge holding tank. So 2045 is a big year for the sludge stream, but the thinking is that this would also be a good time to, right, this is a large upgrade. There may be opportunities, right, in 2045 to go with, to explore an alternative like anaerobic digestion. So, and that's something we'll cover off in the resource recovery section, which is next. Any thoughts on sludge? Yeah.
But just back to the centrifuges where you said they're 20 years old and they're getting up there, but they're in good shape and can go another 15 years. Is there a manufacturer's recommendation along the lifespan of these things? Like I'm wondering if we're taking a risk that is.
So that's it, right? We're taking the risk. There are two of them, so you have the redundancy. So if one goes down, that you have that ability to continue to operate. So yeah, and then it is a cost that would be added to phase 4. So that is another consideration. I agree. And that is, sorry.
I was just going to add that we've, with Carolo, with Piero's help, we've carefully assessed this piece and balanced the impacts of adding that cost to the phase 4 upgrades versus the risk and approach for continuing to use them. So our conclusion is that we do have we can take significant mitigation measures to keep those units in place. We're doing some major upgrades on them this year, and our plan is to have some of the key spare parts on the shelf, so that if and when we do have a breakdown, we can respond much more quickly. The lead time on those parts is what's proven to be the most time-consuming kind of piece in the past. So yeah, we're hopeful that we can get 10 to 15 more years out of these units and help to spread out the capital cost for the system, and that the residual risk, after taking into account we have the redundancy of the second unit and having those parts on hand, kind of mitigate our risk. Yeah.
Jim, did you have a no? Okay. Oh, sorry. Kevin.
Just out of curiosity, so you're going to vent the H2S. Where's it go? How do you treat it?
It goes to an odor control facility. So there's a set of 2 wet scrubbers that basically pull the H2S out. So so the H2S likes to, it'll solubilize in high pH, and then so there's a high pH stage, and then they use hypochlorite to oxidize the H2S. And then from there, the air from that wet scrubber is piped through a carbon scrubber and goes to a stack. So that tall blue tube, if you want to call it that, is kind of the ultimate outlet for the odor and all of the ventilation. So this would be categorized as an odorous unit process. So that would be vented to the scrubber.
I wonder if it would make sense to take a break now and come back, and then we could finish your presentation.
So we're just at resource recovery.
Does that
Perfect.
make sense to you?
Perfect timing, yeah.
Okay. Could we reconvene at 10 after? Would that suit everybody? Give everybody a chance to have a stretch and get a cup of coffee or a glass of water if they want? Great.
Thank you for your presentation.
No.
We're going to come back together in a couple of minutes, so if I can get you to join us again. I feel like such a downer. You look like you're having a good time chattering away.
Good, good. Not bad.
It'll seem to ever get. No, okay, it seemed to be a lost point on everything here. All this is in place.
Yeah.
Okay,
Worst case scenario.
we are going to reconvene here if we could. We're pretty much on track. Going to hear from Piero and then we'll hear from Mike. And if Mike needs more time, we'll break for lunch at noon and then reconvene, give him more time afterwards.
Okay, so the next section is, so there are 2 more sections to go. And this one is recovery of resources. So this came out of the liquid waste management plan, kind of the recommendation that that resource recovery options be considered as part of the facility planning. So the 3 that we looked at were reclaimed water use, heat recovery from wastewater, and implementing anaerobic digestion as a way to both manage the solids, but also for biogas and nutrient recovery. So I'll just kind of go through each of these 3 options and where we landed on them. So the idea of the heat recovery is that effluent, even in the dead of winter, is still going to be well above 10 degrees Celsius. So there's a lot of energy, heat embodied in that water that can be recovered with a heat pump. So similar to how households have the air-to-air heat pumps. And this idea, this approach has become more common at other wastewater treatment facilities. The idea at the Comox Valley plant would be to use that heat for building heating during the wintertime, and then they have an existing boiler system, and that could be used as a backup. I'll just go through these 2, and then we have like just a cost assessment to summarize. Another option from a recovery perspective is reusing effluent. The municipal wastewater regulation, they kind of define what effluent can be used for depending on the treatment. And certainly there are many processes on site that currently use potable water that could be replaced with reclaimed water, especially with the tertiary filtration. In addition, there's an opportunity to do on-site irrigation. So this does represent the combined, it represents a significant portion of the total potable water demand at the plant. So replacing that with reclaimed water is possible, but you need some pumps. We need to add some disinfection, some hypochlorite dosing. So there's a cost to that. And we've kind of we've assumed we've eliminated the option of going off-site for reclaimed water use, just because the cost is very high and the demand is not there, and there are other kind of complications around the disinfection that are problematic. But ultimately, just even if we just consider the on-site reuse and energy recovery, they're challenging to implement because it's very expensive to implement these options. What this table shows is kind of the summaries of the calculation of cost and the payback period. So the amount that you save over time is the amount of savings, the length that it takes to pay back the cost from those savings is longer than the expected lifespan of the equipment. So the economic drivers right now are just not there, but certainly the non-economic drivers are very compelling. This idea of improved sustainability, lowering greenhouse gases, and saving energy is extremely compelling. So it's not that they're being discounted, it's just for this next phase, they're not being pursued, but they will be considered separately. And certainly grant funding would change the calculus. So a lot of the other facilities that have implemented heat recovery, for example, have come with upgrades that have included grant funding specific for that. So there are opportunities, I think, down the road. So on the anaerobic digestion side, so implementing anaerobic digestion as a way to recover the biogas is another option. So currently, the dewatered sludge is composted and sold as Class A compost. Skyrocket, so it relies on the demand for Skyrocket to be increasing at the same rate as the population grows. So if there's a gap, then you'll get surplus, and so you need an outlet for that sludge. So there's a risk to this composting process. So it's whether it's the change in demand or changing regulations. So the thinking is that this anaerobic digestion could also be could be an alternative pathway for the outlet for that solids, for the sludge, but can also provide resource recovery value. So it's kind of like a dual purpose kind of asset that you could implement. In anaerobic digestion, I think I put this slide up once before, but anaerobic digestion occurs in the absence of oxygen. So you put sludge in a vessel, you heat it up, and the natural organisms are converting the sludge to part of the sludge, approximately 50%, into biogas, which is mostly methane. It's about 65 to 70% methane. And digestion, the digested sludge out of the tank can be used for land application, and also the nutrients in that digester are solubilized, so it opens up an opportunity for recovery of nutrients. And then ultimately it can be that digested sludge can also be composted. So you can continue to do the composting. You've kind of taken up some of reduced the volume of sludge that needs to be composted, and the digested sludge composts faster. So there's a benefit to the compost facility, gives you another opportunity for reuse, and you have the resource recovery options. Yeah.
Just out of curiosity, as you guys talk to Fortis, they're all about, naturally produced,
yes,
methane, natural gas, and putting it in the system. Is that even a possibility?
Yes, so exactly. So the facilities, Metro Vancouver owns Lulu Island. They put in so they have anaerobic digesters, and they take their biogas and they run it through a carbon dioxide scrubber. So so biogas out of the digester is kind of in that 65 to 70% methane range. To get it to utility grade, you need to you remove the carbon dioxide and get it to 95% methane, and then you can put it back into the utility, and that's what Fortis is selling. They're selling the biogas that's been upgraded from either digesters, landfill gas under provincial regulations. If you exceed a certain size, then you have to collect your biogas or your landfill gas, which is also high in methane, and Fortis will upgrade it. They'll buy it either unupgraded, like just kind of raw biogas, and they'll upgrade it themselves, or you can sell them the upgraded biogas. So that's an opportunity for sure. Yeah. But yeah, in this case, the gist of kind of these slides is that anaerobic digestion, and that'll be in the facility plan. It doesn't make sense for the Comox Valley plant right now. We're just not at a scale that makes it worthwhile. So that's where 2045 becomes kind of the next point where you're doing all these upgrades to the sludge treatment process. That would be a good time to rethink sludge digestion, and it can be staged. So you can start with just digesting primary sludge. You know, the secondary sludge is a bit more complicated to digest. So there are options, and I think that's the best approach. So focus on the stage 4 upgrades that kind of involve the mainstream process, the high priority stuff, and things that kind of are really in the gray area like this are worth carrying over and considering at a future date. So another option is this thermal drying. So when we talk about, so this is another way, if you run into trouble with, again, because the solids needs to continually be moving off site, if you run into trouble with either because of regulatory changes, so province, there are contaminants of emerging concern that occasionally need to be addressed through those regulations, or because of the change in the demand for compost. Thermal drying is a way to also address that risk. So basically, the sludge out of the treatment plant gets dried into these little pellets, dry pellets, which then can be land applied, or they can be used as a feedstock for a high temperature thermal destruction. So you still get the heat out of it. If it's pyrolysis, you can get it'll be a biochar, like a charcoal, which can be used as a soil amendment, or it's ash if it's a kind of at a higher temperature. And that can also be used for, it's used in concrete and cement production. So it has a potential for beneficial use.
Yeah, Jim? Yeah, just a comment of composting anaerobically digested sludge.
Yeah.
I would anticipate that your levels of metals in the sludge would be much higher because now it's been concentrated by anaerobic digestion. So trying to meet the things like your copper and your selenium requirements for OMAR might be difficult.
So so what happens is that through the digestion, in addition to nutrients being released, you also release some metal. So that is something that it's a good point and worth kind of highlighting that metals is. I just want to make sure that I get that addressed. So it might actually be neutral because some of that metals gets into the liquid phase and comes out as centrate, so goes back to the treatment process. So yeah, I've seen it both ways.
John? So for methane harvesting, like I've met a few dairy farmers who do that, and they've got pretty much, I'm going to say, lower volumes of waste than the plant here. It's pretty cost effective. And if it's not cost effective to do it for selling it to Fortis because you've got to upgrade the percentage, why can't we use it for on-site energy production?
That's exactly the kind of the motivation for doing that is to you can use the biogas in its raw form. It has sulfur in it, the hydrogen sulfide, so you have to be a little bit careful about how you burn it because it will destroy furnaces, like if you're using it in a boiler. But yeah, it used in a boiler, it's perfectly fine. Yeah. Yeah, it's just the cost of because of the scale, the concrete tanks, and all the other kind of supporting process equipment. So the gas handling is very onerous because under the biogas, there's a code in Canada that basically you cannot emit, if you're doing any kind of these digester landfill gas recovery, there's no allowance for any kind of discharge of the methane because of the greenhouse gas potential. So you need all kinds of redundancy. So the process between the concrete and the process support is just it's a very expensive process to implement, which is why there's a threshold, kind of a population threshold that is typically used. And the Comox Valley plant is really just at the bottom end of that population threshold where it makes it's economical. So it displaces all of these other, thickener. Well, you'd still need a thickener, but you wouldn't need all of the sludge storage. It does make it more cost effective overall, but you're just kind of just too close to the bottom end of that range to make it cost effective.
If I may, Pietro, are any of these, do these options differ in terms of the CO2 emissions to the atmosphere, or how much, on the other hand, they lock in of carbon? And is there any difference? Are carbon credits an issue or a consideration for any of the options?
So that's where the biogas recovery is, I think, super is compelling because of the Fortis. So you can sell it to Fortis. So Fortis is happy to buy all the biogas that you can produce at a very good, because they turn around and sell it to consumers at a elevated rate, right? And so you can actually you can do well selling. It becomes a good way to from reducing the carbon footprint, right? Like reducing CO2 emissions, and then the recovery of and it's low. The emissions are low, and if you've designed the system to reduce or eliminate any of the methane emissions, then that would be the way to go. The dryer is also good, but it needs a heat source, so it would have less of maybe a larger carbon footprint than maybe biogas. That would be between the two options, that would be the way to go. Is the anaerobic digester would be the lower footprint. Did I answer that? Is it? Yes. Okay. Okay, and so that covers off resource recovery. Any other thoughts? So, yeah, reconsideration at a future at the 2045, or as the regulations for composting and changes. So we're kind of really in the tail end now. So I'm just going to present the staging plan for the 4 phases. So just to identify what the scope is for each of the phases that we have now on a preliminary basis. So the stage 4 plan, which is kind of the next set of upgrades that are to be completed before 2030. And it's probably the biggest scope of upgrade. So it'll include a new electrical service, new headworks, which we talked about in that new UV disinfection facility, the tertiary filtration that is going to be there for the wet weather treatment, the bioreactor upgrades, updates. We talked a little bit. We kind of just touched on, but they're also informed by the process optimization expert that kind of worked for a little over a year, and we worked with him to come up with some strategies. And ultimately, it comes down to aeration control and finding ways to improve the settleability of sludge. The effluent pump upgrades, so something we haven't talked about. The outfall is reaching capacity. So there was a condition assessment that was done this winter, which showed that there is room for some additional pressurization of that outfall. So the way that the near-term approach for getting more capacity out of the outfall is just to increase the pumping capacity. So during those high tide events and coincident with wet weather, there is a need to pump into the outfall. So that's what that upgrade is all about. And then an upgrade to the administration building. So it's a facility that was built in the 1980s and needs to be brought up to code and then expanded to provide for additional facilities for operations to take the CVRD to 2060. And then there's a little bit of odor control upgrades to support the headworks upgrade. So I think that's it. So yeah, this kind of describes it reasonably well, and I can talk to any of the other items that I didn't specifically, smaller items that I didn't talk about. So the SEPT is also part of that, and something called the mixed liquor splitter chamber, which is a feature that will allow better redundancy on the primary clarifier or the secondary clarifiers and bioreactors. And then, so that's stage 4 or phase 4.
Let's see if there are any further questions or concerns about these this strategy.
And yeah. So the facility plan will kind of really there's some of these features that will have a lot of support, a lot of assessment that's been done to come down on this specific approach. So that there's a lot more detail coming.
Yeah, exactly. I was just going to say, keeping in mind that this is only the first contact point with this information, a great summary by Piero. The detail will be coming for you to read this summer, and then we'll have another opportunity to follow up and get into the details or questions or concerns.
Ian?
The accountant in me is coming out again.
Yeah.
Any assessment of the tax impact of this?
Yeah, that will absolutely be part of the analysis coming forward to you in the fall and in the winter. Yeah, so once we have more accurate cost estimates, we'll be presenting them in terms of approximate tax impacts. So that's a lens that you can view them through. Yeah.
Jim?
I'd just like to say I'm really pleased to see the consideration for UV disinfection. I think, with norovirus and everything else that we have now, disinfection of the effluent is a really good step forward, and anything necessary to facilitate that is a really good move given the amount of shellfish growing we have around the area. So yeah, that's great.
Yeah, and the tertiary filtration will also really help that along.
Okay, we'll let you just sit with that for a while until the next round of presentations. And
I can go through there's just 3 more slides.
Oh, okay. I'm sorry.
And so just to kind of keep going, like so, I just wanted to. So phase 5 would be a 2040 upgrade, and bundled into that are the. So we need that fourth primary clarifier, and then we talked about the increased dewatering centrifuge capacity that'll happen then, and then because both primary clarifiers and centrifuge are stinky processes, there'll be a need to do some odor control upgrades. And then 2045 is that's a big one. This is secondary clarifier and bioreactor. So 4th secondary clarifier and 4th bioreactor, as well as the sludge storage and gravity thickeners that we talked about. And then finally, in 2060, it'll be the 5th primary clarifier, some additional sludge storage tankage, and then again, because of the stinky process, there'll be odor control upgrades. And that takes you to 2060, and that is that's the end of my slide. So any thoughts or questions?
Just looking at that 2045, was there anything in there for the centrifuge upgrades at that point in time where we're talking about
2040.
limping them through?
2040. There they are.
And so that would mean replacement in that case, kind of
Yes,
thing?
absolutely,
Yeah.
replacement. So the full replacement of that. Yeah. Okay, thank you. That was great. Some good questions, and we'll make sure I've taken a couple notes. But after this, I'll sit down and ensure that we, as part of the final plan, that we like it's just kind of these blind spots that sometimes it's worth. It was great to get your feedback on. And the questions were excellent.
Thank you. Okay, we'll turn it over to Mike then. And we'll take a break for lunch at noon. And if you don't have enough time, we'll reconvene with you afterwards.
Sounds good. Thanks, everyone. Just let me figure out how to share my screen here. Oh. Okay. Everyone's ready to continue. I'm gonna present on source control here. I'm just gonna try and take these captions off actually, unless people like that. That's awesome. Yeah. I think I got it. Okay. So yeah. So just want to take a quick step back here and just talk about the liquid waste management planning. So Piero just kind of described, you know, the kind of the big infrastructure project associated with the liquid waste management plan, which is the treatment plant. You know, that's kind of like the meat and potatoes, if you will, of the liquid waste management plan. There's other aspects of the liquid waste management plan. They're called planning components. And these are sort of like the garnish, the parsley, the salt and pepper that go along with the plan. And what there really are the ongoing sort of management processes around what the CBRD does with their liquid waste. So I&I reduction, there's been a lot of discussion today about that. Will be one that'll the long-term sort of how will the CBRD reduce, along with the member municipalities, how will they reduce I&I? That's a long-term management plan. What I'll be presenting on today is another one of those that related to source control. So hopefully that brought some context. So what is kind of source control? So source control is a set of best practices used to discourage and reduce what we call problematic pollutants at their source. So we have treatment plants that treat the wastewater, but source control is focused on trying to prevent those or reduce them from getting into the sewers in the first place. And here's just like some examples. The oil and grease is one of those examples that clog sewer pipes. Pharmaceuticals is another one. Toxic chemicals, industrial and commercial inputs to the sewer system. The wipes, what are in a category called obstructive wastes. And then just another one down here, just representing what we call contaminants of emerging concern. So, what, like I said, the main objective of a source control plan is to reduce or eliminate certain pollutants from entering the sewer in the first place. But really, it's kind of a multi-tiered uh, objectives, protecting utility and public workers. If these get into the sewer system, they can pose a risk to the workers that are working on the sewers and the public. Uh, Gas or flammables, for example, can cause explosions, um, prevent damage to infrastructure. So, a good example is a clogged sewer pipe that that would need to be replaced on and another big one for the CBRD, because we're producing the skyrocket compost, is protecting or improving the quality of the biosolids there. So preventing things like we talked about metals earlier, Jim made the comment, making sure that, we don't get excessive amounts of metals into the sewer that could potentially impact the quality of the compost. And the big one, well, second biggest one is protecting the wastewater treatment plant. So making sure things don't get into the sewer that can cause issues for the treatment process, which Piero just went through. And then the biggest one, obviously, overall, is protecting the receiving environment. So just take it back to the drivers for why we're talking about source control. As I mentioned, source control is one of those garnish sort of components of a liquid waste management plan. But like Chris mentioned at the beginning, a big part of this is to address the ministry's comments on the stage 1 and 2 plan. The stage 1 and 2 plan source control, it was mostly focused on the big picture. What are the options for treatment? Source control wasn't necessarily considered. The other aspect is meeting the Ministry of Environment's liquid waste management guidelines. Like I said, the source control planning component is an important part of liquid waste management plans, and the ministry looks to have that addressed as part of their approval process for approving the liquid waste management plan. And also, we talk about the regulatory requirements. So the municipal wastewater regulation is the main regulation that will govern how the discharge from the sewage treatment plant. And part of that regulation requires a source control bylaw to be in place if the treatment plant is accepting what are called non-domestic waste. And I'll get into that a little bit further in some next slides. And then the other part of it, again, one of the points of why we're all here today is to have this engagement. It's one of the purposes of the technical and public advisory committees is to be that first sort of pass at the public at the engagement process, which is very important to a liquid waste management plan. And during the stage 1 and 2 process, there were the broader sort of engagement with the public. It identified that the public did have concerns with some specific what I'm calling problematic pollutants. So this is the opportunity to incorporate and address that feedback. And this is still a little bit of overview here on source control for everyone. So there's 2 main approaches. At the top there, we have educational approaches. So these are things like, public education and outreach, printed brochures, social media, public workshops. The CVRD currently has an educational page on their website called "What Are You Putting Down Your Pipes?" That's an example of an educational program. So it's aimed at educating the public on what basically not to flush down your toilets and your sinks. And the other approach is a regulatory approach. So you can implement a source control through implementing what's called a sewer use bylaw. These are mainly focused at this sort of non-domestic category. So large industrial, if there are any, large commercial or institutional facilities. So different types of contributors to the sewage collection system that either have like a very high volume or a very high pollutant load. So a bylaw can sort of allows a local government to regulate those discharges from those specific types of facilities. So those are the two main approaches. So you know, I could keep those in mind. Yeah, please.
If I heard, you said implemented through the sewer use bylaw for the regulatory. Have there been any implemented, or is that just a measure that you can try and go forward on?
Yeah, so I'm gonna get to that. Yeah, no, it's a very good question. So part of, and actually this slide will explain it here. What we're doing as part of addressing this source control planning component is we're reviewing what the CVRD and the member municipalities are currently doing related to source controls. So that's our sort of baseline. What are we doing now? We wanted to also review sort of what are the potential problematic pollutants specific to the CVRD, because every municipality or regional district may have some slightly different ones. And when you develop a source control plan, you want it to be focused on your community specific needs. And then from there, so we kind of review the background, then we developed recommendations for what will go into the liquid waste management plan. And then we go through this consultation process and then finalize what the CVRD is going to commit to within the liquid waste management plan with respect to source control. So we're kind of in the middle here right now, where we've done the background review, which I'll present next, and then we're working towards finalizing the commitments. So the current source controls, so going back to those two approaches, the educational. So the CVRDs, like I mentioned, has a few web pages on the website. What are you putting down your pipes, and then a very good septic system education, both very good educational sources for the public that are focused on, what are you putting down your pipes is focused on obstructive waste, proper disposal of pharmaceuticals, and keeping toxic compounds out of the sewers. And then the septic system fact sheet is relevant because the treatment plant also accepts the septage from all of the pumped out septic tanks in the region. So that gives a lot of good educational sources on, you know, how to maintain your septic system to, you know, what to avoid putting into it. And then in terms of the regulatory, yeah.
Curious again.
Yeah.
So would the septic system education also go to any actual staff being hired to look at septic systems? And there was some good discussion last meeting about that.
Yeah.
And we covered off, okay, we can change the pipes and all this, but what about the other part of there's tons of septic systems out there with whatever oversight or lack thereof? That's all.
Yeah. So
Mark has some good background on CVRD.
Slightly off topic. I'm just curious.
I'd just start off by saying, if I can, Mark, that so septic systems are regulated by the regional health authorities. So they're the jurisdictional authority on those. But you know, for every regional district, there is, because it you know, there is concern about it. So maybe Mark, you can.
Yeah, thanks. So one of our managers, Derry Monteith, who can't be here today because she's at a different meeting, but she's spent quite a bit of time kind of looking at what can be done to better manage septic systems in the rural areas. So like Mike said, the province is responsible for, you know, the permitting and management of septic systems. But the regional district can work with the province kind of in partnership in implementing, you know, more controls. So they could implement mandatory maintenance, could do all sorts of things. But what the regional district has done in the past and what we will continue to do with the support of the board is education programs. So we've had several, visited several different communities, Royston, Union Bay, Saratoga Beach, the Gulf Islands, to provide education on the proper maintenance of septic systems. But that's as far as we've gone. And then we've done a bunch of investigation on like a mandatory maintenance program. But so far we haven't implemented anything mandatory beyond what the province requires.
Is that to say you would be able to do that and it's just in the queue, or you still need legislative delegation or something?
Yeah, we would be, so we do need the province to provide the authority for us to do that. So that would be one step. Also, a new service would be required. So that's another step that requires elector assent. And so there's quite a bit of work to do to implement a program like that. So Derry's done a bunch of that investigation, and yeah, right now we're not suggesting that we go down that road, but it's definitely been looked at, and you know, we could in the future, but
Just wanted to follow up to that, Kevin.
Yeah,
just highlight that that question is somewhat out of scope. Yeah, but there is some overlap. The treatment plant, particularly when we come to source control, because the treatment plant does process all of the septage from the rural area. So the septic systems themselves aren't within the service area, but we do receive all of the septage from when those tanks are pumped out. So I just wanted to flag that. But as far as what Mark's mentioning there, those activities, the new service, that activity at the staff level is happening outside of the Comox Valley Sewage Service, not a part of this planning process.
yeah, maybe just one more thing to add. I think the education part is probably the most important part, at least related to here, which is the source controls, right? So it's education about what to put in your septic system and what not to put in it. So
the final comment, I know I'm off base, is I said at the last meeting, and one of the members was talking about the fact that they're on a joint septic with their neighbors, and there's times they can't flush because the whole backyard's flooded. That doesn't sound like a really good management. I'm just sort of wondering if this is something that can be addressed in the future. I realize it's only partially to this program. It just seems like a need. That's all.
Yeah, good question. I think it's a little bit complicated when it comes to septic systems, and you know, definitely I think through the liquid waste, this is a little bit off topic for source controls, but I think, you know, through the south region addendum, you know, where the CVRD is looking to expand the collection system to previously serviced or houses previously serviced by septic systems, is one example of, you know, looking at how, you know, septic systems can be incorporated within a liquid waste management plan. But yeah. So just to continue on here, so there's currently some pretty good educational sources out there that the CVRD has initiated, and the other main ones are regulatory related, and they're two bylaws. They're actually at the municipal level, the Town of Comox bylaw number 713 and the City of Courtenay bylaw number 1327. So these, when we talk about source control, so these bylaws really are focused on, you know, prescribing what can be discharged in a sewer for those. And again, their focus is on those non-residential or non-domestic connections to the sewer system. So these two bylaws currently, they're slightly different, but they do contain a lot of the aspects of a source control bylaw or a sewer use bylaw, where they describe and list the prohibited discharges and substances, and include sort of the standards for discharge and connecting to sewer systems. And then for potential these non-domestic users, for example, an industrial user, a good example might be a brewery or a food manufacturer that produces a wastewater through their process that isn't just normal flushing of toilets and normal domestic waste. These bylaws include requirements for what's called pre-treatment. So some measures at those sites to treat the wastewater before it enters into the sewage system. And then again, they also contain some provisions for offenses and penalties for violating the bylaws. So getting that, and then moving forward to question? Yeah, sure.
Go ahead, Mary.
Yeah, I just wanted to ask about educational. I'm just wondering, both of the educational ones are more of they're embedded within web pages, and so you'd have to go looking. And so I'm wondering if there are any ideas around having perhaps more active ones, like the fire department. I think they link changing your batteries with Halloween. Would the CVRD be able to have kind of a set date where they remind people to take their pharmaceuticals back to their pharmacy, any unused pharmaceuticals, to remind people of what should and shouldn't go down their drains, etc., on a more, like, it's every year, this is when we remind everybody actively, rather than people have to go hunting on a website? Because I just think the people that care might go there, but that doesn't capture a huge audience, I don't think.
Yeah. Yeah, very good question, Mary. So I think your question is, should we have more active educational programs? And so the answer to your question is, as I'll present here, is the absolutely yes. So as part of implementing a more robust source control plan, the recommendations are going to be for the CVRD to enhance their educational and awareness components related to source control. And this is where the TACPAC, the input and feedback from the TACPAC really comes into play in terms of actually deciding and defining what that ultimately looks like. So does that answer your question?
Yep, thank you very much.
You're welcome. So the next slide here is just sorry about that. Oh. The next slide here is just, we did a preliminary review of the users within the CVRD, and we looked at the zoning maps and various other publicly available sources to just identify, everything other than the typical residential neighborhoods and households. What other types of users does the CVRD have? So this chart just shows, some of these industrial, commercial, or institutional users. So for example, there's 5 breweries in the area. There's 17 dental offices. There's 10 photographic operations and 33 food services. So each of these users can potentially be discharging one of these, again, problematic pollutants into the sewer system that could be the focus of eliminating before they enter. So having an understanding of the user characteristics will allow the CVRD to sort of tailor their source control plan to what is actually within the sewer service area. That we also identified that there was some industrial parcels. There's 12 in the CVRD, 11 in Comox, and 146 in Courtney, but the majority of these were actually light industrial. And they may not actually be producing, although they're zoned industrial, they may not actually be discharging into the sewer what are typical industrial waste. They may just be a warehouse, or actually one of the facilities on in a industrial site was a yoga studio, for example. So we know they're not discharging industrial waste. But that is to say that my final point here is that we did identify a need to perhaps understand more exactly those potential industrial, commercial, and institutional discharge or users within the region, to evaluate the compliance with the current bylaws. Are they, because we do, the town of Comox and city of Courtney do have the two current bylaws. Are they currently in compliance? And also understanding those sources more will help inform the development of what we're talking about, is this more robust source control program that will go into this liquid waste management plan commitments. So just to give an overview of the outcomes and benefits. So based on the stage 1 and 2 public consultation process, there was lots of comments around concerns around and priority for protecting the environment and the infrastructure. So implementing the source control program is expected to be well received by the public. And again, it allows the CVRD with the opportunity to really tailor a program specific to the community specific issues and priorities. And it also allows a more robust regulation for these problematic wastes. Some other main reasons why people do these things is, again, they're best practices, but they also help, I mentioned previously, protect the infrastructure. So the sewers as well as the treatment plant. One positive outcome is those of source control programs is that they can lead to reduced capital costs and operational and maintenance costs associated with the infrastructure, and help sort of prolong the life of the existing assets. Yeah, some other things here, again, in relation to the liquid waste management plan, demonstrate further action to address public and stakeholder feedback, meet the regulatory requirements, as I mentioned earlier, and meet the ministry's expectations for including this source control component within the stage 3 liquid waste management plan. So the kind of key recommendation so far on source control is to develop it. We don't need to develop the full source control program within the liquid waste management plan report, but the liquid waste management plan report should say that the CVRD commits to implementing a form of source control and provide a timeline that will describe by this time we will do these educational campaigns, or by this time we will implement a bylaw. So it doesn't have to be done but there has to be a framework established to do that in the future. So the two main things, so there's the town of Comox and Courtney sewer bylaws, and as I mentioned, those bylaws are a good framework and foundation, but they are slightly different. they're intended mainly to protect the sewer conveyance system and not necessarily the treatment plant, because the treatment plant is operated by the CVRD. So what we see there is a real opportunity to strengthen and also harmonize those two bylaws, so they agree with each other, and they say the same thing, and they also consider source controls related to protecting the treatment plant infrastructure. So that's the primary recommendation. That'll also should allow a strategy and policy for consistent application and enforcement across the region, and in particular related to these non-domestic discharges, the industrial, commercial, and institutional. Currently, based on my previous slide, there aren't a lot of those right now that are a major concern, but that doesn't mean there won't be in the future. So having a bylaw in place, a robust bylaw in place, would allows the future regulation of those potential larger ICI users. And then the second component is again related to Mary's question, to develop and execute additional educational campaigns focused on at the domestic users primarily. So some topics that were discussed during the stage 1 and 2 liquid waste management plan process were public concerns related to microplastics. So we probably all heard a lot about these. They're in a lot of different products that we use every day. So an awareness campaign and education around what alternatives to ultimately prevent and discourage the use of products containing microplastics, because they do end up in the sewer system, can impact the infrastructure, and then also the treatment infrastructure. The other one was that the public had concerns around were around persistent organic compounds, and well, we've probably all heard the forever chemicals, the PFAS. So again, this might be a very good topic for an educational campaign, bringing awareness to the sources and alternatives to ultimately reduce the quantity of these chemicals getting into the sewer system. Pharmaceuticals was also another one, and personal care products. So more education around proper disposal and products to avoid, and obviously avoid flushing them down the toilet. And then the other big one, is a concern for most local governments operating sewer systems is non-flushables and hazardous household products. So again, just more education around proper disposal and options for preventing discharge to the sewer system. And again, what those educational programs look like, and they can take different forms. They can be, more still maybe web pages, but making them more visible. There can be social media campaigns. There can be, pamphlets mailed out, like a mailing campaign, public workshop, or a public open house to have education. So that's really up to the CVRD to decide. And again, it doesn't need to happen right away. But what the liquid waste management plan is going to look for here is to make a commitment to explore and implement these in the future and define what they look like in the future. And then the final recommendation here, as I mentioned before, was again to just conduct a survey of the industrial, institutional, and commercial sewer users. again, just to identify what they are, uh, or identify if there's any major non-domestic dischargers, and that again, that can also be used to inform how the bylaws could be strengthened and adapted to, you know, account for these, you know, user groups within the system. So those are the three main recommendations. Again, the overall commitment is to develop a framework for an effective source control program, and then strengthen and harmonize the current municipal bylaws, and develop additional educational campaigns.
Thanks, Mike. I wonder if what we could do is break for lunch now and come back for questions. Would that be okay?
That's fine by me. And
Yeah. Okay with the team? You arrived at the perfect time. So if we could maybe come back at 25:02, I think Michael lunch is
there.
It's there? Awesome. And maybe if we can reconvene at 25:02 and we'll come back with questions
Sure.
for Mike.
Hopefully there's none.
Super. Thank you. looks like as predicted, we have a full agenda, so I'm going to be a taskmaster here. And we'll get Michael back here to carry on with source control. I've lost all control.
Thank you. We just sit down. There is a gap.
No, I won't use. There it is.
There.
Oh, there's a handle for something.
Yeah.
Yeah. Okay,
The pace.
Michael, we're going to give you the floor again, and we'll let people take their seats.
Take our seat.
That got their attention. Thank you, Mr. Chair. So, Michael, you're at a point of questions now? Anything
Yes.
else that you wanted to say?
Yeah, no, that was everything. I know it was fairly quick. Just reiterate for everyone again, the source control component of the liquid waste management plan. There's nothing a lot like very technical there. It's really focused on those two approaches, the educational and the regulatory approach to prevent or reduce or prevent certain contaminants before they get into the system. And it's I use the analogy, it's the garnish. The big infrastructure is the meat and potatoes, and the source control is one of the garnishes. But I think it's more source control is maybe your spouse or your partner telling you that you don't need as much salt on your meat and potatoes. So yeah, and again, just also to emphasize, all these, exactly what the source control program looks like doesn't need to be decided before the liquid waste management plan gets prepared, but the key aspect of it is that there's a commitment to develop that going forward, and a certain framework. Again, the key recommendations to harmonize and strengthen the municipal bylaws, and to consider some additional educational campaigns.
Okay, questions for Michael? Yes, Mark.
Is there any talk of like expanding facilities to dispose of like hazardous waste? Because as of right now, I think there's only at the dump you got to go up to, so it's like kind of inconvenient for a lot of residents. So easiest way is just to dump all those chemicals into the sewer because it disappears right away. So
yeah, for sure, that's a good question. I'm not aware of that. Those are typically like private business ventures. And I'm not aware of any in the CVRD, and definitely not necessarily the CVRD as a municipal treatment plan isn't really mandated to collect those sort of toxic waste. That's a whole other permitting process. So I don't know if you have anything to add to that, Chris.
Just to echo Mike's comments, although I will make a note, and it could be an opportunity to collaborate with our solid waste department to see if there's any opportunities to make it more convenient, because you're right, when it's not convenient, it does, whatever it is, it does make it more likely that people will not comply or do the right thing. So thanks for the thought.
Yes, John.
What have other municipalities that are successful at this done around enforcement?
So sorry, your question was what have other municipalities?
Yeah, other municipalities that are successful at source control. What have they done with enforcement of to gain success?
So there's a couple of really good examples on the island here. The Capital Regional District probably has one of the most comprehensive source control program, which includes all those educational things, as well as a really strong regional bylaw. The regional district of Nanaimo also has a strong source control program. Same approaches. Both of those, you know, a big part of this, the bylaw part of it is enforcement. So I can't really comment on to the extent that at which those are enforced. I can just say that the enforcement is critical to, you know, realizing the benefits of those, especially as it relates to those industrial, commercial, and institutional users. Another example would be Metro Vancouver. So I know that they, you know, they obviously have a lot more industrial users, so they heavily enforce their sewer use bylaws. Um, um, so a food manufacturer is a good example. You know, someone that produces cheese or dairy products. They have like a high strength, high volume wastewater from their manufacturing process that they don't have their own discharge to the ocean. They dump into the sewer system, so they're quite heavily enforced. And part of that is actually a permit. They, before they can even discharge, they need to have a permit. So that's the first step of enforcement, is making sure those users have a permit, and that permit is granted by the authority having jurisdiction, which in the case of source control is the local government, so the city or the regional district authority. So yeah, and there's I would say, just broadly, I've seen the level of enforcement vary quite a lot. Some local governments enforce quite heavily. Others, they have the bylaw, but they don't necessarily enforce it very strongly. But it is important to actually realize the benefits of it, that there's a consistent, you know, regular enforcement of those bylaws, starting with a permit application and approval process.
Thanks. Jim?
Was that?
Oh, sorry.
I could.
Jim?
Yeah, earlier it was mentioned about education that the CVRD does for septic tank users. And a potential of reminding people, you know, annually or whatever. I think it would be real advantageous to follow up with the septic haulers as well, because they are picking up a lot of these materials and disposing them at the treatment plant. And I know there's a regulation in place for that, but a reminder to the haulers that certain types of waste aren't permitted, because sometimes even within the municipality, the sewer use bylaw won't allow discharge of a certain type of material. So they put it into a holding tank and they call the septic haulers to come and get it.
Yeah.
And they take it out to Reed there and he gets it.
Yeah, no, that's a really good point, Jim. So I think, like, within this sort of regulatory approaches to source control, when you have, you know, a certain user group like septic haulers, you know, you can engage that user group, and part of what can go into a source control bylaw is what's called a code of practice. So, you know, the best thing to do is engage with that group and try and, you know, come to a consensus on, okay, what's the standardized practice for septic haulers, like you say, what to do and what not to do. So most local governments that have these strong source control programs and a associated bylaw have developed these codes of practices based on specific user groups within their community. So yeah, that's definitely something that, you know, again, having committing to the framework of doing this is what's important now for the liquid waste management plan, but what it looks like in the future, that's, you know, that will take more planning and more discussion around. So at a point in the future, you know, that could be a good aspect of the program that could be incorporated.
Thanks for that. Any other questions about source control? No. Thanks, Ken.
Do the operators of the wastewater treatment system have any idea which are the major problems? You know, it would seem to me that the focus should be on the you know, targeting industries or organizations that are the major problems.
Yeah, that's another good question. So which are the actual problematic pollutants for the CVRD in relation to the treatment plant? And Reed's probably the best one to answer that, but I will just say part of also what we're doing, the bigger picture here, Chris mentioned the environmental impact study that's being done as well. And part of that is to sample the raw sewage coming into the plant, and not just the typical parameters that are regulated, like the BOD and the TSS that Piero was describing earlier, but really everything under the sun to understand, you know, is this exotic chemical somehow getting into the CVRD's collection system? So that more comprehensive sampling is being done, and that will inform, you know, anything that's problematic more from an environmental standpoint. But then from an operational standpoint, there's certain things that are definitely create problems for operators that Reed probably knows best.
Yeah, it's like you mentioned, it's hard to quantify on some of the other stuff that we don't have data on for the PFAS or the microplastics, how that could be impacting the treatment plant itself. But the general day-to-day operations is the flushable materials. That's what's clogging pipes, strings around valve stems, things like that. And fats, oils, and greases is always a concern. Dealing with, you know, that's part of regular maintenance, but the less in the system, the easier it is to control that maintenance or have some unexpected failures on things that you can't control. So yeah, we've the flushables, you know, small things like that people don't think about, like dental floss and stuff that ends up getting flushed down someone's toilet. It's really strong material that just wraps around things, and it starts all the rest of the flushables start to build up, and it becomes a bigger and bigger issue, right? So yeah, there's definitely some more education that we can do on the things that get flushed down the toilet, and fats, oils, and greases is always one that as much as we can keep it out of the pipes for sure.
Yes, Sheila. And then we'll go to the virtual members.
Is there a testing program? Do you have employees who go out, I don't know, once a week, once a month, whatever, sampling in the sewer system throughout the region to see what they find? Or is this maybe just a special project once in a while?
Good question. I'm not aware of any sampling that's being done within the sewer system. Definitely at the, you know, the front of the treatment plant, that's regularly sampled. Within the sewage system, again, it's important to understand that the sewage systems are under the authority of the member municipalities. So there's that jurisdictional boundary. The CVRD operates the treatment plant and the big collection pipes that collect all the sewage from, but then the sewers within Comox and Courtney, they're operated by those municipalities. Reed, are you aware of any?
No, I'm not sure what the city of Courtney or town of Comox have been doing on that front, if they're doing any testing at all. But yeah, we're just at the inlet to the treatment plant. It's, you know, the pump stations themselves, like you mentioned, is a large catchment for big areas. We know there's some smaller lift stations. We know some stations that have problems that are maybe more with fat soils and greases and things such as that, or where pumps might be plugged a little more frequently, but there's no actual analytical testing done outside of the treatment plant.
It might be useful for you. I realize you'd have to get permission from Courtney and Comox, but ongoing regular testing throughout the system can give you good information.
Thanks. We'll go to Caitlin and then to Martin. Caitlin?
Hi everyone. I just had a quick question. I'm wondering like if there was a sense of what the sort of mechanisms for monitoring and inspections would be for commercial and industrial users in the source control bylaws, like if there's an indication of what that will look like at this point, or sort of what the general goals are for that.
Yeah, good. So what the monitoring and did you say what the monitoring and sampling looks
Yeah,
like?
no, I just wonder if there's like I mean, obviously there's like some maybe implications that there will be permits for industrial users, and I wonder if there's going to be a sort of like site inspection component permitting to like check for compliance.
Yeah, okay, good question. So this is up to, you know, the CVRD and Town of Courtney, or City of Courtney and Town of Comox, what actually they want to do with respect to that. There is a very good Canada-wide what's called the Model Sewer Use Bylaw that a lot of local governments use to prepare their bylaws, and sort of has standard frameworks for those things. Definitely, a lot of it is based on sort of self-reporting. So that the discharger that obtains the permit, they will have to submit reports to the town or the city, whoever the enforcement body is, on a regular basis, and the bylaw should describe at what frequency and what the details are of those reports. And generally, you know, if a new permit is issued there, that's a trigger point for an inspection by the authority. And from there, there's provisions in the bylaws to allow the local authority that gives the permit to sort of enter the premises at any time to conduct an inspection. So there's a pretty good standard framework, but ultimately those decisions are up to the local governments that are, you know, preparing their own tailor-made bylaws. And that, again, that model sewer use bylaw is a very good example, and I know a lot of local governments have used that as the basis for drafting their bylaws.
Maybe I missed this when you were going. Oh, sorry. Go ahead.
No, go ahead, Caitlin.
Well, I was just gonna ask if there's like an expectation for a certain level of agreement between the different municipalities when we're working on the source control bylaws.
Yeah, I don't know, Chris, are you better to answer that one?
I was just gonna highlight what Mike mentioned earlier, that the part of the intention is to work towards synchronization or harmonization of the two bylaws that Courtney and Comox have in place. And while we still have some engagement to go on that, the engagement we've done so far, there seemed to be some general agreement with that approach. I don't think what Mike didn't mention was we did look at potentially implementing a regional source control bylaw, but the decision after engaging with the municipal staff was to strengthen and potentially harmonize the two existing municipal bylaws. So yeah, that is definitely our intention, is to work towards a consistent regime across the whole service area.
Okay, thank you.
Thanks, Caitlin. Martin?
I was just thinking, this is partly a comment and question. I'm struck, I think there are huge strides that could be made on the educational side and sort of public educational side and source control. Huge gains could be made. And I regard myself as a fairly observant, law-abiding, thoughtful citizen who should know stuff that I simply don't. I'm super ignorant. I'll tell you how. I have a garage full of paint and toxic liquids of all kinds, some small quantities. I don't know what I'm supposed to do when I'm cleaning my paintbrushes with paint thinner and the gunge that's left over. What am I supposed to do with that? Let it evaporate into the atmosphere? I've been pouring it down the drain. Am I supposed to? I don't know. Is that the right thing to do? I don't know. If I take a gallon of oil-based paint that I don't like anymore, if I take that gallon and I haven't done this, and I poured it down the sewer, which I could do because I know where I could do it, where it wouldn't affect my domestic system. It would just get straight into the, there's kind of a 6-foot long tube beneath an iron plate in my lawn, right? I can easily pour it down there, get rid of it. Does the system actually, does the sewage treatment plant actually digest that successfully? Am I actually doing any damage? Is it designed to handle that gallon of oil-based paint? So these are questions I have in my mind. I mean, does it end up in the sludge? Do the chemicals end up in the sludge, or do they get evaporated somehow or burned up? What happens to it? What's the chemistry of it? So what I'm saying is, I don't know these things, and I think a lot of people in residents in the valley are as ignorant as I am. Anyway, I just throw that out. I just think there's huge strides to be made.
Yeah.
I think, Martin, you just made the case for an education program.
Yeah.
Yeah, no, great questions and comments, Martin. Yeah, I think what you're saying there is just really, again, stressing the importance of that educational component as part of a broader source control program. So like I mentioned, an effective source control program has those two main components, that the regulatory, the bylaw, very important, but education equally important. And yeah, a lot can be gained there.
Could I just say, is there anybody in the room that could actually answer technically the chemistry question I'm asking? Like, is the system designed to handle gallons of oil-based paint flowing through it? Like, technically, is it?
I think if you can't see the room, I think that's a definite no.
No. But it must be handling, because there are people, I'm sure there are people do this.
I think that's probably true.
Yeah.
Okay, I'm going to suggest we push on to Chris. I think you're next up, right? Yeah, you're next up for an update on the outfall path forward. Unless there's any other burning questions. Thank you, Martin, for that. I think that was awesome. That was an awesome conclusion to that discussion.
Thanks, everyone.
Thank you, Mike.
Thanks, just bear with me. Okay. And here we go. So yeah, the next piece we wanted to update you was on regarding the outfall. So there was some attention provided the outfall in the stage 1 and 2. Just speaking to some of the results of the past inspections and what we knew about the capacity constraints, particularly as mentioned earlier, during periods of high tide. And then we received the response back from the province, and they highlighted they really wanted to see more, and specifically when the outfall was slated for replacement, and they wanted to see that within the LWMP stage 3, and if it was as previously considered in need of replacement in the early 2030s, they felt that it should be part of the detailed design package because they wanted to see a Class B cost estimate for the value of that project within the planning horizon. So we've done quite a bit more work over the past few months or year. So I'll summarize that to you. If I can get this thing to move. There we go. So first, just so we all know what we're talking about here. So there's been a lot of emphasis on the treatment plant this morning, but after the treatment plant does its job and the effluent leaves the plant, it travels through an outfall approximately 3 kilometers along the beach and then just under 3 kilometers straight out into the ocean and discharges at a depth of about 70 meters through a diffuser, which helps to spread and dilute the effluent into the ocean marine environment. So it was constructed at the same time as the treatment plant in 1982. It includes an onshore and offshore section, as I mentioned, those lengths, and then the diffuser section, which is about 120, 150 meters, and it's got quite a large number of ports on it that help to achieve the dilution that is needed to reduce the impact on any one spot within the marine environment. The vast majority of the time it flows by gravity. The only time it needs a little bit of help is during those periods of high tide, particularly in the king tide time of year, which just happens to coincide with when we have the highest I&I flows, which is normally in November and December. So there's some issue there. So at the beginning, right from the beginning, the plant was constructed with a effluent storage basin. So there was like a lined pond built that's still there on the east side of the plant, and it was designed to act as a bit of a capacitor. So during those times of high tide, when it doesn't drain quite as well by gravity, the flow would be diverted to that basin, slowly fill up, and then as the tides fell, it would release it, and when necessary, use some pumps that are in that basin to help push it down the outfall. There's the schematic on the slide here, but I just realized that it's probably pretty hard for most of you to see. But it just describes how the flow from the plant usually goes straight out the outfall, but is diverted to the effluent storage basin, which is where those 3 pumps are at the top there. And another thing to note is that while there are pumps and they do help to empty that basin during extended periods of peak flows and tides, they don't exactly pressurize the outfall. They increase the head in so you can see that on the very right is the outfall chamber. It's kind of like a large manhole. And what the pumps do is they effectively raise the elevation of the plant by raising the level in that chamber. But it's not actually considered a force main because it is just gravity pressure at the top of that chamber. And that's relevant when we talk about the likely solution moving forward here being to pressurize the outfall. So just to refresh on the key stage 1 and 2 LWMP outcomes regarding the outfall. So kind of the context. So the first one is that inspections of the offshore section of the outfall are required on a regular basis, and they've revealed some corrosion and areas where there's been a bit of a separation of the pipe. We've since done some a follow-up inspection, I think, since these decisions or recommendations came out of the stage 1 and 2, including some dye testing where we inserted a dye into the flow at the plant at the outfall chamber, and then had divers with and/or an ROV kind of cruising over the effluent, the outfall pipe to see if there's any leakage or to see where there's leakage. And so that did confirm a couple of spots of minor leakage. The second piece is that the capacity of the outfall, and this is the bigger one, and certainly the well-known one, the capacity is a concern during those periods of high wastewater flows and high tides. Sorry, the other piece that I should have highlighted on the last slide, apologies, is that in 2018, because of those capacity issues that I just kind of revisited there, we did add a effluent storage basin that Piero was talking about earlier in the context of the diurnal equalization. And so that basin was installed because of that acknowledgement, per the second bullet here, that we were nearing capacity in the pre-existing system. So that the primary purpose of that new basin is to act similar manner to the original basin, but at a different point in the treatment process to divert primary effluent kind of outside of the normal process to, you know, while we're experiencing those periods of high flows and high tides, and then once the tides go down, pump it back into the system. And so that's been working well. The second to last one is that the outfall at the time was based on the analysis done by our consultants, was looking, you know, we were looking at the early 2030s for likely replacement on the basis of the capacity. And that the last piece there, just upgrades, including a new outfall pipe with pumped assistance, was recommended for future flows. So the current challenge, just to summarize, capacity limitations during those peak flows and high tides, the effluent storage basin and the pump station are used in those situations. The primary equalization basin was commissioned in 2020 as a stopgap measure to take us through to the early 2030s. While the pipe itself is not the limiting factor, increasing flows to the outfall will exert additional pressure on the pipe. So we're looking to gain a better understanding of the condition of the outfall pipe. So that's where we kind of started or ended the year last year. And then the final piece there, that as I highlighted earlier, the ministry in their response letter to stage 1 and 2 really wanted to see an update in the level of analysis on the timing and cost for the outfall replacement. So before I dive into what we did to better assess the condition of the outfall, just wanted to show this graphic here to explain the different components of the outfall. So the onshore section in red, the offshore, and they're roughly equal in length, about 3 kilometers each, and then the diffuser at the end. There's some photos here just showing some of the inspection results from the remote operated vehicle in 2023. We don't have a photo here showing the leakage of the dye, but there is another photo showing just kind of a greenish yellow small plume coming out of the 2 different locations. One where the pipe has kind of separated at the beginning of the diffuser, and another sign at a place of corrosion. But just to add to the offshore sections, you know, that type of deterioration is somewhat expected for a pipe of 40 years that's been in the marine environment. So I think the conclusion, working with our consultants to date, has been that if the decision is made to continue using this pipe to extend the life of the pipe through pressurization, that these small bits of damage could easily be repaired. So to assess the onshore section, which is a different pipe material than offshore. Offshore is steel. Onshore is a concrete, steel reinforced concrete pipe, similar in material and type to the pipe that runs along the Willamar Bluffs from Goose Spit to the plant. We set out to undertake a condition assessment of the pipe, which was quite a challenge. In our earlier condition assessments using similar technology for the pipe from the Courtney pump station all the way to the treatment plant, we had the ability to access the Courtney pump station where the instrument was launched and the treatment plant where it was retrieved. But as you can imagine, with the outfall pipe, with it terminating 70 meters under the ocean, We had to find another means to recover the instrument. And so we, looking at the as-built drawings for the infrastructure, we noted some access hatches that were included in the original design. Didn't really have reliable as-built for this section, so we spent several nights during periods of low tide, which occur at night during the winter, trying to locate the hatch, and finally did find one. So you can see the top right circle has a bit of a culvert sticking out of the water. So that's about half at the half tide level. So what we did is when we finally did find that hatch, we put a vertical piece of culvert around it to stop the sand and rock from kind of filling the hole back in, put a heavy lid on it, and then that allowed us to access the hatch without having to re-dig it up every time. And then Reed and his crew worked with our contractors and inserted this instrument shown on the left, which is referred to as the pipe diver, and it uses electromagnetic emitters and sensors to scan the steel that is reinforcing this concrete pipe, and so it was inserted at the effluent storage basin, which I think that the center photo is showing it's being lowered down into that hole, and it had to be lowered down and then turned into a horizontal output pipe, and then held there to wait for the right conditions, both from a tide perspective on the beach, and then also we built up a significant volume of wastewater in the storage basins, so we could send this instrument down the pipe with the right flows and maintaining the right velocity to capture some good data for the pipe. And then on the right there is our operator hanging out at working on the hatch. The contractor had to insert a grate into the flow to act as a barrier, so that when the instrument came floating down, it stopped at that location. Then we were able to stop the flow from the plant by diverting all the flow into the storage basins, and then opening the hatch, removing the instrument, and recovering the data. But it was quite an operation. A big effort on our part, big effort on the part of contractors, and a fairly significant expense too. The results were positive. I mean, and we were pretty optimistic that they would be. This pipe is exposed to relatively low pressures, and not much in terms of variability, as opposed to the force main that goes to the plant, which is subjected to very regular shocks as the pumps come on and off. This pipe is, like I said, largely gravity and fairly low pressure. But it was really great to see these results. There was just two sections that showed any evidence of deterioration of the reinforcement. And I won't dive into the details of the graph at the right, but it does show that even those two sections of pipe that showed a very slight bit of deterioration, if we were to raise the pressure in the pipe to what we're thinking of doing to extend the lifespan of this infrastructure, it doesn't take us anywhere near the failure mode of this particular type of pipe. So on the basis of that positive condition assessment, our recommendation as a path forward is to proceed with the infrastructure upgrades that are necessary to put a modest pressure increase for the outfall. And so to do that, we would incorporate the required upgrades into the phase 4 scope that the Carollo team is working on the detailed design for, and then they would output the Class B cost estimates needed to insert into the LWMP process. And that would be changing the pumps. So the circle there are the pumps in the effluent storage basin, the basin that's been there since the start of the plant from the early 80s. And then the effluent outfall basin, is the red square at the bottom right, which will need to be modified along with some valving and piping to allow that outfall to actually be pressurized, because we're looking to boost the pressure by about 12 psi. So yeah, so that's our recommendation, and the commitments that we're planning or thinking of including within the stage 3 LWMP are to include those interim upgrades and the associated costs as part of the phase 4 upgrades. And then to review the timing of the full replacement of the outfall. It's possible that in the future, we'll certainly, actually another commitment is likely to be that we will revisit or redo the condition assessment. We now know exactly where that hatch is, should make it a lot easier. But we're likely to, we'll certainly, do another condition assessment within the 10-year period, and particularly if we are hoping to further extend the life in the future. But with the positive results of the condition assessment and the recommendation to extend the life, that does push the actual replacement of the outfall out beyond the horizon of this LWMP. So it would be something that would be looked at as part of the next planning process, roughly a 10-year horizon. Yeah, that's it. That's all I had on the outfall. But it's quite a bit of information. Any questions or concerns about the proposed approach?
Relatively good news.
It is.
Yeah.
It is good news.
I didn't want that to pass by. Any questions from those of you online? Okay. Derry is going to join us. Did you want to carry on first? Is she?
Mark might be.
Oh, okay. Mark, over to you then.
Yeah, thanks, Allison. So Derry, if she had made it back in time, she was going to join us, but she's attending a different meeting today. So I don't think she's going to make it, but she's prepared some speaking notes for me, and I'll read through these and then we can have a discussion and answer questions. So yeah, this topic, there's no presentation here, just a verbal update, but this is an update on the South Sewer project, but most specifically focused on the Union Bay Estates property sale that's happening right now, and you know how that impacts the project. So as many of you have likely heard, the Union Bay Estates land, formerly Kensington Island Properties, has been listed for sale by court order. We understand that this raises many questions about the property, the impacts on Union Bay community, and of course the proposed wastewater service. CVRD heard last year that conditional foreclosure orders had been filed against Kensington Union Bay properties associated with the relevant mortgages on that property. So prior to this news, the CVRD had been working together to formalize financial commitments to the project, and partnership funding had been included in the budget estimates. And that's important. So the estimates that we put out to the community, the cost for homeowners, that was based on a three-way partnership between the CVRD, Union Bay Estates, and Comox First Nation. So their negotiated contribution had a big impact on those costs being what they were. So recognizing now that Union Bay Estates may not be able to meet the financial commitment made to the Sewer Extension South project, we've been working to find alternatives that could see the project move forward as proposed. So the first obvious one that we've been looking into is whether we can seek additional grant funding to make up some or portion of that commitment. Should further funding not be realized, construction will have to move forward in smaller phases in order to keep the project affordable for residents. And those potential changes in scope are being looked at now by staff. So we don't have anything to present in terms of what that could look like, but that's, it's a concept that we're looking into. Project affordability has been a key concern raised by the community throughout the engagement on the project, and will remain a key consideration for staff as we review those options. The project remains a priority for both the CVRD and Comox First Nation, and will continue to move forward in partnership with KFN. The legal process for Union Bay Estates has continued, leading to the property being posted for sale. we will be open to discussing a potential funding partnership with any new property owner, as the development of the land requires connection to a community wastewater system. Our planning department is managing questions about the master development agreement for the land. A new owner will either have to follow the MDA or seek changes through an application to the Electoral Area Services Committee. Beyond that, there's not a lot more we can say about the project or about Union Bay Estates, but we'll continue to keep you and the community informed about any future steps. So that's the update on South Sewer. But I'm happy to take any questions that we can answer and have a discussion.
There are a couple of questions. Well, let's go to Ian first and then Mary next.
So I guess my first question is that this funding arrangement is fundamental to any approval of the addendum for the sewer extension south. How does this affect the overall liquid waste management plan, given that that addendum in some ways is invalid now? Does it get extracted from this? Does it, have to then get reapproved and then reinserted into this process? Because I don't, as a member of that, I don't feel good about saying, let's move forward, continuing to explore solutions if that remains a valid document.
Yeah, no, good question, Ian. So the only way that we could continue to move forward with the existing LWNP, and it has been submitted to the province for review, so just to be clear, is if nothing changed. So if the funding, like if somehow Union Bay Estates managed to get themselves out of this situation and wanted to continue to be a partner and essentially nothing changed, then we could suggest that we would continue down that road. Or if a new owner, purchased the property and we quickly came to the conclusion that South Sewer was the way to go and the commitment was appropriate, nothing would change. But it doesn't seem likely that that's going to happen. And so we haven't done it yet, but I would suggest that at some point the stage 2 report would be withdrawn and it would have to be reworked to to accommodate the project in whatever form it takes on, right? So we haven't done that yet, but that's, it's either going to continue as is, but if it changes, it has to be redone.
And as a quick follow-up, is there a timeline when that decision will be made?
I don't have a definitive timeline, but I would say within the next 4 months or something like that, probably.
Mary.
Yeah, forgive the naivete of this question, but as a proud owner and steward of a type 3 system on a very small lot in Area B, I've wondered about how many septic systems are down at Union Bay, what the cost of tying that in would be, what the cost of tie-in per household was estimated at, and whether it was ever explored the notion of instead of providing tie-in to the pipes, provide grants or low-interest loans for households wishing to upgrade to a proper, really high-functioning type 3 system on their property.
Yeah, so thanks, Mary. And I'm not going to have all of the numbers for you as part of the answer, but there's been a lot of analysis done over the years looking at all of the different options. And I think one of the biggest reasons to continue to pursue a community system, especially for Union Bay, but also for Royston, but Union Bay is designated as a growth node. It's very close to treaty settlement land, large swaths of treaty settlement land for Comox First Nation, and to the pre-zoned land for Union Bay Estates. And so it's known that at some point in the future, there's going to be urban, more urban style development there, like more dense development, I should say. And that really, would be most appropriately supported by a community system. And so that's a big part of the reason. But there's been a ton of work done on looking at those different options of, septic systems to a higher standard, the sort of ground conditions in that area, Bain Sound as a eventual receiving environment for the treated wastewater from septic systems. So yeah, lots of effort put into that.
Any other questions? Oh, I'm sorry, John?
Am I right in saying we still need voter assent from the residents of Union Bay to move ahead?
So the liquid waste management planning process, one of the benefits of the process, or yeah, one of the features of the process is that once a liquid waste management plan is approved by the province, an elector assent process is not required. So the process of going through a liquid waste management plan, and I think you've heard people here refer to the 8 years that they've been involved in the very lengthy and complete planning process, including all of the public and stakeholder consultation that's completed. Once approved, it provides the local government with the authority to borrow the funds required. So in that way, it kind of replaces the elector assent process that might come from a referendum or a alternate approval process.
Yeah.
Okay. Oh,
I just have a sort of quick plan about a communications plan. You know, this isn't generally known by, well, I didn't know anything about it till today, but that's because I don't drive through Union Bay. When is this going to be sort of announced, sort of formally, so the residents of the affected communities are going to know officially?
Yeah, we will be. So I think we already have updated the project page for the South Sewer project. And I think we also have some letters planned. We're just trying to figure out the right timing for those.
okay, bummer for those of us that work part of
I don't know if
you
it's a
guys.
bummer or not. That's the problem.
So much work, right? Okay, thank you, Mark.
Okay, thank you.
Appreciate that. And then we'll go back to Chris.
Thank you, Allison. And thanks for everybody for sitting through 4 hours of pretty intensely technical material. So I've just got 2 more slides. They're not technical. We're just talking about the process moving forward, which I hope reflects an appreciation of the very technical nature. Where we do have 3 more meetings planned between us and the final plan submission. Another meeting to focus in on the material that Piero has presented on the site master plan. A summer of review. So here, I'll just share my screen again. So you know what I'm talking about. Yeah, so just looking at the timing moving forward. So summer 2025, as we talked about earlier, we do plan to share the full site master plan. So the executive summary that was sent out which was I believe was about 15 pages. The site master plan is closer to 400 pages. So we do consider that some light summer reading for you over the summer. We're happy to, in fact, we'd really encourage you to send us in any comments or questions that you have after reading that document, so we know what to focus our presentation on in the fall when we come back together. But don't worry, I mean, if you don't get around to that, don't worry. We'll be providing another overview and trying to tease out any concern areas and for further discussion. Between now and into the winter, we'll be continuing our engagement with the Comox Chief and Council, just to ensure that their full engagement in the process and support for where we're going. We'll be working with Mike and his team at WSP to draft the stage 3 report. So fall 25 to winter 26, as you'll see on the next slide, just with our meeting schedule, we won't have the draft ready for our next meeting in the fall, but there will be a draft circulated in advance of the subsequent meeting. Working towards that submittal to the province in by late spring of next year. And then we're anticipating 6 to 12 month review by the province. And then so hopefully approval of the plan in 2027 so we can start delivering the phase 4 upgrades, which we currently expect to be complete by the end of 2030. Apologies for the small text here, but this describes the next and hopefully the final 3 meetings in this very long process. So the first one in fall 2025, so I expect that probably in early October, but we'll definitely get an email out to you with plenty of notice so you can get that into your calendar. And so that one will be coming back to discuss, as we've already discussed, coming back to discuss any TACPAC concerns or questions, comments on the site master plan, and then present and discuss the remaining LWMP components that we touched on earlier, including the INI and that whole other list of items. And as part of that, actually as part of the site master plan that you'll be receiving this summer, we will have the Class D or Class C cost estimates and impacts to users presented there. When we jump to the next meeting, that's when we'll have first eyes on the draft LWMP stage 3 plan, including any changes to the major components since we meet in the fall. And at that point, we will have slightly higher level of cost estimates, more of the Class C, including projected tax impacts to users so that we can be very, very clear on that. And then fast forward to when Piero and his team have completed the Class B cost estimates. That'll be the final component that will be weaving into the advanced draft LWMP. And in between those 2 meetings is when we'll be consulting with the public. So at that point, rather than, it'll be more of an informed type of engagement at this part in the process. And then we'll be summarizing any kind of feedback or outcome from that public consultation into that final version, which we're expecting to be complete in spring of 2026. And we'll have that fourth and final stage 3 TACPAC meeting. And at that meeting, I've also flagged, in addition to voting on approval, hopefully, of the stage 3 plan, also discussing a plan on establishment of the plan monitoring committee, which will be for those keen individuals interested in maintaining some involvement in this going forward. Yeah, so that's it from us. Yeah, big thanks again for coming today. And are there any questions about the process moving forward before we adjourn? Kevin.
Perhaps not exactly the process. I've just been driving, between Comox and Courtney, and they worked on one end, and now they're working on the other end, and what's happening in the middle? Just curious.
Conveyance, sure. I'll give a quick conveyance project update. So I think we're well over 80% complete now on the pipe portion of that project. And so you're right, it does definitely seems to have jumped around. So the pipe component has been delivered by 2 contractors, one working almost entirely within the town of Comox, and then the other working to the east and west of the town. And I think we've definitely thought along the way that we did a good job of kind of threading the path of the conveyance project through every jurisdiction and sensitive area that we could between Courtney and the treatment plant. So some of those constraints have driven how the project has been delivered, which explains some of why it's kind of been working here and there. It's working around archaeological concerns, traffic, and then jurisdictional time of year, you know, the water levels in the ground. So yeah, we're down to the last couple sections now. So you see them marching their way up Comox Hill right now. So that's happening at night because it's a narrow road width there. So they've been shutting the road down entirely so that they can work on that section at nights. I think they started about a week ago and they're getting towards the top. So then they'll tie into the pipe that's already complete all the way across the town of Comox. And then the last section will be through IR1, so KFN IR1. So that'll be happening over the coming 3 months or so. And then a little bit along Jane Place too, from Beaufort down to the Comox pump station on Jane Place. Yeah. Yeah, so we're hoping that the major traffic disruption will be complete by September, October. So that'll be when that full section of IR1 will be finished and the rest of it's done. And Waycor's will be working on the roundabouts at the top of Comox Hill. So that's another, so it's not just the pipe install, but it's been some of the surface works for the town of Comox that have also been causing traffic delays. So yeah, we're hoping that the unidirectional flow of traffic will come to an end in the fall. Yeah. Yeah, no problem. Mary, I see your hand up.
Yeah, when do you expect it to go live, Chris?
Well, we hope that the first section that will go online will be from the Comox pump station to the treatment plant, and that'll happen likely late fall or into the winter of this year. So that, yeah, we've been intent on getting that section decommissioned. As you know, that was the major driver for the project, was to decommission the section along Willamar Bluffs, which is most exposed to the wave and storm action. And then the balance, the remainder of it will be brought online early next year. So late
Great
spring,
job.
early winter, early summer.
Fantastic. Yeah. Great job.
Thank you, Mary.
Will there be a party? A ribbon cutting?
Yes, but definitely of some sort. Yes, yes.
I suspect that many of the people that have been around for 7 years might want to go.
Yeah.
It will age out. Any other comments or questions? Those are great updates. Thanks, Chris. Great. Thank you. We can adjourn then. Thank you, and we'll see you in the fall.
Yeah.
Thank you
everyone.
all for being part of this.
Thank you.